Okay, so I guess we will start tonight. Everything is here. Okay, so how many people are new tonight? All right, cool deal. So basically what this is, I don't know if you know who I am. Basically, I'm known as Eli the Computer Guy. I've been doing tech education on YouTube basically since 2009. The idea with Silicon Dojo is I have met people literally around the world that have been empowered by my education, all the way from Italy to Amsterdam to Cancun to the south rim of the Grand Canyon. And basically the idea is, what if we started doing tech education basically in the real world? What if we made tech education as accessible as a YouTube video, but actually in person? So when I started doing YouTube videos back in 2009, everything in the world was in person, and being online was amazing. Like, oh, what if there was this on-demand stuff? Of course, time changes, and so now it's 2006, and everybody is now at home doing everything online, and so we're trying to just bring this back to the physical world, and so that's what the idea with Silicon Dojo is. So we have a main website, silicondojo.com. If you come here, basically we use Meetup for the RSVPs, but any kind of classes or kinds of things are going to be here, so you can just keep track. I do want to start doing classes in Asheville again, so I'm from Asheville, North Carolina. So if you're willing to come out to Asheville, this will be a place where you can say, oh, there are some Asheville classes I might want to go to. Also on here, I'm a little late with it, but with these in-person classes, so I have a video camera back here, and I have a little mic on. So I'm recording these videos. If you miss the class or you want to watch it again later, you can come to Silicon Dojo and you can watch the class. Also, so you know, I've done fireside chats. I plan to do more of these in the future. So these are with actual, technology people that are doing things. Again, the VP for AI models for IBM, we talked with him. We talked with the CEO of a $2 billion cybersecurity company. So basically those are where I'm talking with people about the real world technology, if you're interested in that. And we also have the self-study programs. So when we're doing a lot of these classes for Silicon Dojo, we're going to be using Python as our primary language. We're going to use Bottle as our primary web app framework. We're going to use SQLite as our primary relational database engine. So if you don't come to one of those classes, like we just literally had a full one-day class on Introduction to Python on Saturday. If you can't attend like one of those types of things, these self-study programs are there. Like the Python series is something like 50 parts to it. We've got SQLite, we've got Introduction to Programming, those types of things. You can just sign up and just, learn them. And that's what's there. So if you're interested, this is its own little membership site. It doesn't cost you anything to become a member. I would suggest you do become a member, because then I can put out email blasts and that type of thing. It's like, when you're on Meetup, you pay Meetup, but you don't really own Meetup. Whereas the nice part about this thing is I actually sort of own this platform, so I get your email addresses and all that kind of stuff. This is all free to the end user. Again, one of the interesting things that I found, I came up with the concept or the wording for free to the end user back in 2012. I was actually at the AOL headquarters in Baltimore doing a speech, and I had to figure out what the hell I was doing. Because again, in 2012, nobody knew what YouTube was. So it's like, how do you get paid? What is this thing? So it's like, oh, free to the end user. So the idea is you abstract out the financial component from the education component. Payment happens, education happens, they are separate. What we're trying to do right now is crowdfunding. We've actually gotten a decent amount of money in crowdfunding. We're right about $30,000 total so far. But that's what pays for my hotel room. I have a hotel room. I drive here. I eat food. I pay for the office, all of that kind of stuff. If you would like to support, basically the idea is if you have the money and you find this to be valuable, you're all adults. How much money you want to throw in there, that's your business. Basically, I don't check on any of this for any resources that you get. So if you want to have a one-on-one meeting with me, you want to come to a class, I never look at the financial component, but things do need to get paid for. So that exists. One thing for everybody to remember is I actually forget about this site. It's weird. I spent like 15 years building this thing, and now I forget about it because it's in the past. There is EliTheComputerGuy.com. If you come here, you will find a metric crap ton of education. So these are the classes that I built up over many, 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 many years. So again, you've got like Linux old. You can go back to, I don't know. I think these are videos like from 2010 when I did Linux videos. So we got Linux videos from 2010, and we have like Linux videos from 2019. So anyways, there's some education for you too. Everything that we do here, I do put all of the class information on GitHub. So if you go to GitHub/SiliconDojo, when you go to in-person classes, all of the documentation and code is here, workbooks and everything else. If you are interested in teaching your own classes, one of the ideas here is not simply to that this is the product, but also the idea of creating a system that is replicatable. So if you want to take this information and you want to go teach your own people, teach kids, teach adults, teach your employees or whatever else, feel free to take all of this information and run with it. And so let's see here. The final thing is I have not scheduled the classes for February yet. I have some personal stuff going on that's having to figure things out. But basically we are going to have a class, a skills class, hopefully on using Twilio and 11 Labs to create voice AI systems using telephony. Hopefully that'll be coming up on the 11th. We are going to have a full-day class on Introduction to SQL and the Model Web App Framework for building web applications. That'll be coming up on one of the Saturdays, and then we'll probably have a networking class. So those classes are going to be coming up. I just have to schedule them. And that's about it. Oh, and for the next full-day class, just so everybody knows, I do want to put as small a barrier as possible to people showing up, right? And that's one of the reasons we're using this room. So now I can shove 100 people in. Doesn't matter how many people show up. When we do the in-person classes, I can only mentally deal with so many people. Trying to figure out dozens of people, like where they forgot to put the comma, kind of drains me after a little bit. So we can only do about 24 people in those classes, 24, 30 maybe. So one of the things I'm going to do is the next class, it is going to cost money. It's going to cost you $1. That is just going to force you to actually put your credit card information in to prove that you want to show up. That's literally, oh no, it's $1. It's like that pays for nothing. That's just forces people to think, am I really going to come to this class? So anyways, that is the start. Any questions? Any questions? Everybody can hear me. Let's make sure, because I feel like it's very, anyway. Okay, so Introduction to Programming for Artificial Intelligence. So this might be a bit of a wackadoodle class. Hopefully it's not too wackadoodle. Wait a minute. Where is my, as I say, not too wackadoodle, where is my thing? Is that it? Hold on one second. There we go. So basically, like I said, I was here on Saturday and taught a full day class. And I was here, this is like the fourth time I've been to Research Triangle in the month, and we're still a third of the, or 2/3 of the way through the month. So I created this class. Hopefully this all makes sense. It is kind of weird being an educator. You sit down to write a class and then you get to the end of it and you're like, I hope all of this comes together to actually be valuable to somebody. Anyways, so if it's a bit wonkadoodle, it is what it is. So the first thing that I want to talk about is one of the big questions that comes up is, will AI kill programming? So I hear this, again, it's one thing when you hear it from the 17-year-olds, whatever, they're 17, they're stupid. The problem that I hear from a lot of people is, I've actually been hearing this from old timers, like the 40-year-olds, the 50-year-olds, the people that have already been through a lot of the tech revolution, and there's this idea that artificial intelligence is going to kill programming. Kids should not learn how to program anymore, which is stupid. It is just stupid. If you want to do technology, you have to learn how to do programming. Like, it was weird. Like 10 years ago, there was this idea, everybody needed to learn how to program. They did not have to know how to do CPR. They did not have to understand how the stock market worked. They did not know how to cook, nor did they have to know how to change the oil in their car. But everybody had to learn how to code. You know, I know, that's dumb. There's like some other skills that should become before coding. But anyways, what's really weird now is everybody's flipping the script. And now there's this idea that basically, because AI is out there, nobody needs to learn to code anymore. And that is just as idiotic as the crap that they were saying about 10 years ago. And the reason is, two reasons for this. One, learning how to code is not that difficult, depending on what you're doing, right? So there's coding and there's computer science. So coding is building scripts. So when you come to Silicon Dojo classes, you're going to come, and if you come to the full day classes, you're actually going to learn how to build useful things in a single day. Like, you can do that, right? In 40 hours for writing programming, or for normal programming, you can learn how to create functional, useful things, valuable things that basically you can use in your organization to make life better. There is computer science. One of the things, a lot of people go into computer science programs, and it's really weird. They focus on the computer, and they kind of miss that whole science part. And that's the thing, is in the science part is all the very complicated math and all of that kind of stuff. Computer science is going to take you a long time. That takes 4 years or whatever else. But just learning how to program any of these programming languages, you spend 40 hours, so basically about 1 week, learning how to program, and you will be good enough to have the basics of programming. So if you want to do technology, you still need to learn how to program. And when I say that, I'm not saying you need to take a year out of your life to do it. I'm just saying you need to sit down about 40 hours, a couple of months of sitting down a couple of hours a day, you should be fine. And the reason is because you need to be able to read what the hell like AI is giving you. Like, it's really weird. My lived experience, especially doing this whole mentorship thing, I do a lot of mentorship. Like, I was talking to this one founder, and this is no lies, this was back in the day. They had spent between $200,000 to $300,000 developing their platform. Their platform did not work at all, like did not function. Anyways, I asked them, okay, well, what is it developed in? Like, maybe it's really complicated, C++ or whatever else. And like, PHP. Like, what? Okay, fine. You paid somebody PHP, God bless, whatever. So anyway, so I was sitting there, and I was talking to the person, and they had said all these amazing things about their CTO, right? Their technical co-founder. Eli, you've got to understand how amazing this technical co-founder is. Okay, so it's like they had spent $200,000 to $300,000. They were out of money. Their code did not work. And so I just sat there, and again, I said just normal advice, nothing like big. I was like, you know what, just have your amazing CTO audit the code, figure out what the hell's going on, and move on. It's like, oh, he doesn't know PHP. You're like, what? Your technical co-founder, you're literally building on PHP, and he doesn't even know PHP to the degree to audit code. What the hell are you people doing? And again, they have burned through hundreds of thousands of dollars. And so one of the big things to be thinking about with programming and anything in the technical world is, at the very least, you need to be able to audit this crap. You need to be able to understand what the hell is going on. What is a front-end language? What is a back-end language? What is a database language? What is the difference between a record store and a data store? Why would you put something on Azure? Why would you put something on DigitalOcean? What is the difference between a private cloud and a public cloud and a hybrid cloud and all of those different types of things, right? If you're going to be a technology professional, you need to understand these basics. And I think that's one of the things that people really get lost on. When we talk about vibe coding, so a big thing nowadays is like, CEOs and C-levels are starting to vibe code. Eli, we don't need a tech department. The CEO is going to vibe code. So if you watch my videos, if you ever watch my YouTube channel, I don't recommend it. But anyways, when I do, when I'm on there, one of the things I scream about is technical people don't seem to think CEOs have real jobs, which is weird, right? There's this idea that CEOs make money for nothing and we're the ones that actually do the work, which is stupid. CEOs have real jobs, and it's a pain in the ass, and whether they should get paid what they should is a whole big question mark, but they have jobs. But the weird part we're getting into now is the CEOs seem to think the technical people don't have real jobs. Like, oh, I can just code this myself. You're like, what the no. So if your CEO starts to vibe code, if your C-level start to vibe code, without very specific reasons, quit. Just quit. Just walk the hell out the door. Why are you leaving? Because you are vibe coding, and that is stupid. The thing to understand with being a technology professional is our job is not coding. It's not coding. It's not racking servers. It's not running cable. It's none of that kind of stuff. Our job as technology professionals is this thing. This is what we get paid for. We get paid for the whiteboard, right? We get paid for figuring out this kind of thing of like, is the technology cost effective? When we start talking about artificial intelligence, we start talking about LLMs. Again, you will hear me say amazing things about the Granite 4 350 million parameter model, right? It is amazing. The reason is because not only will it run on a potato, but as I said, it'll run on a tater tot. Like, it requires no resources to run this thing. And so if you're going to be running this in your environment, you can literally take one old desktop computer, put Granite 4 350 million parameter model on it, and it will just keep trucking along day in, day out, and won't cause you any issues. Won't cost you a lot of money. And so the thing you have to be thinking about is, when you're going to be building out your systems, what is the most cost-effective solution for what you're doing? That's understanding technology, right? What technology scales well up or down? So imagine you're going to be building your product, and what if there is the possibility you'll be the next Facebook? Can your systems scale up to 1 million users? Right? There are a lot of systems out there that are fabulous, amazing systems, maybe up to 1,000 users, maybe up to 10,000 users. But once you start getting above that, there just starts to be problems. They're just not built for that kind of use case. And so one of the things you need to think about is how do these systems scale up and the pricing of scaling up. So like one of the big things you see like with Amazon services. So if you're going to use Azure or if you're going to use AWS, they're great because they're free to start, right? When it's you and your friends and all that using a little platform, it doesn't cost you any money. You start to get a couple of customers on the platform, and it doesn't cost you much money. Here's the interesting thing. You start seeing the bills for some of these platforms, once they start getting 1,000 users or 10,000 users, it's amazing how the price goes through the roof. And so one of the things you need to be thinking about as a technology professional is, again, things like architecture design. So I think about this like video, again, since I do YouTube videos and that type of thing. If you were going to be building a video system, Amazon AWS charges approximately 9 cents per gig transfer. So a 1 hour 1080p video is approximately 3 gigs. So if you create a video platform and somebody clicks on the video and it watches 1 hour of 1080p video, that just costs you 27 cents for one 1 hour video. Again, as I talk about, what if you get 1,000 people watching a day? It starts to get expensive, right? Where the interesting thing to be thinking about is if you have your own local infrastructure. So when I started doing videos, my videos were on Xeon servers in what's called a co-location facility. So you pay, let's say, $1,000 a month for a rack in the colo facility. You pay a couple $100s a month per gig in and out. And that's the thing. A gigabit per second concurrent connection will give you something like 300 1080p video streams concurrently. Again, there's overhead and other stuff, but somewhere around that. Let's say 200. Right, so that's the thing, is you pay, let's say, $20,000 for a server system. You then pay $1,200 a month for the co-location facility and the bandwidth. And that's it. If you have 1,000 people hammering your site, you've still got the exact same $1,200 bill. And again, that's the kind of thing you need to be thinking of as a technology professional, and that's what's not necessarily going to get you anywhere with vibe coding. Things with issues like vendor lock-in. This is going to be a very interesting one. So a lot of these vibe coding platforms, I forget the name of one of them, they've realized that people that are vibe coding don't understand architecture. They don't understand infrastructure. So hey, what are they going to do? They're going to offer you infrastructure too. So you can vibe code and then deploy to their infrastructure. One of the questions you have to ask is, are you getting locked in to their infrastructure? Right? So you're having a system write code you fundamentally don't understand. You don't even understand how to audit this code. It is then going to be using infrastructure that you don't fully understand how it works. And the question then is how the hell do you unwind that if you ever need to? Which becomes a really big question. Things like security issues. Our project's designed from the beginning to be upgradable. How does the technology fit into the legacy stack? That's a big thing with vibe coding. So your legacy, right? Somebody 10 years ago decided to deploy a server system for whatever reason, and you're going to own that thing for the next 100 years. It's just how it is. Like people walk in, it's always funny, like new people, they walk into an environment and they're like, that's crap, it should be thrown away. What they don't realize is everybody agrees with you. Yes, that is garbage that should have been thrown away 5 years ago. The problem is, it deals with critical services on the network, and nobody really has time to figure out what to upgrade it to, and it's a whole Megillah to upgrade and the rest of it, so that legacy system is going to be there for the next 15 years. Grab a seat, anyway. And so those are some of the things to be thinking about with vibe coding. One of the big things when you're thinking about vibe coding is, I would argue vibe coding is a force multiplier for technology professionals. Again, for me, when I'm creating classes, again, I know PHP, I know Python. Hey, I know Visual Basic still. But anyways, JavaScript. I hate JavaScript. It's just me. Look, I have a thing against JavaScript. Again, it's just my personal opinion. I'm an asshole sometimes. But here's the thing. So when I go to do JavaScript, I do need to do JavaScript, but things like delimiters and commas and how do you close stuff, I just forget that. I know exactly what JavaScript is supposed to do. I'm pretty good with the syntax, but I'm not perfect. So what's great with vibe coding or ChatGPT or whatever else is you're like, this is what I need my JavaScript to do. I need to sanitize the variable values that are coming in. I need to do this, this, this. I need to send it off to my backend database. what's the syntax, right? And it'll be able to give that to me, and that's something that's relatively easy to do. That's something you can do with vibe coding. One of the big things that I'm seeing from a lot of folks in the development community now is the idea of basically using vibe coding for things like minimum viable products, like really minimum viable products, like be careful how far you go with it. The idea being is, especially if you're in the startup world, is you want to start pushing something out to people to make sure that they actually want whatever it is that you want, right? There's this idea that I'm going to tell you what you want. And when that works well, that's amazing. You get Steve Jobs. 99 times out of 100, that's not actually how it's going to work. You're going to tell the world what they want, and they're going to say no. So basically the idea is use the vibe coding is to very quickly, right? And again, in a day or two, you can deploy something, you can start to get user validation from people, and then be able to go from there. And we got more people in. Oh, everybody coming in. Try to come about 6. So we got attendance and everything else going on. You are?
Oh, I'm Jesse.
You are Jesse.
Yeah, sorry, I was running late from work.
All right.
Gloves, so thank you.
Oh, all right. Let's see here. I got him, you, people over here. You can keep the paper, don't keep the book. And more people are coming in. And you are? Matthew.
Yeah.
Wiggins.
You got it.
Cool. There. Ta-da. And you?
I am Rao, R-A-O. R-A-O-B-R.
Ram, yeah, I don't know. Whatever your display name is. Rao? Rao. Yeah, that. You okay? I feel like an ass. What is your name again?
Well, it's for Mill, but I show up as something else.
What do you show up as?
RJ.
RJ? No.
No, not RJ.
No.
What is it, a meetup?
Meetup, yeah,
site?
meetup display, yeah.
Show up as RJ. I just joined like an hour ago.
Oh, okay, maybe that's it. Oops. You got one, right?
Yeah.
Yeah, okay. You looking for a bathroom or something?
Water.
Kitchen is that way. I don't know if they have any glasses or anything. Okay, everybody have books? Everybody has books. Books. Okay. Okay, so that's the whole vibe coding thing. Yeah, think about it as a force multiplier for like vibe coding. And again, like this is real. We really have come to the point. Again, the people that I talk to, we're just tired of this shit. It's just like this whole thing that AI is going to take all coding. It's just, I don't know. It's a good story people are going with. So one of the big things to be thinking about if you're going to go out and you're going to start learning to code, and especially if you're going to start learning to code for things like artificial intelligence, is one of the big questions of like, why the hell are you learning to code? What are you actually trying to accomplish? It is interesting right now, OpenAI has come out and they have declared 2026 as the year of productivity. Because, in 2026, they're actually getting around to the idea that AI has to do something useful, which really is kind of a metaphor for where AI has been. And I think this is an important thing. Like, everybody's like talks about AI, but one of the questions is like, what problems are you actually trying to solve for? Like, why are you trying to get into this game? So this is a big thing with folks out there. If you're thinking about coding, the idea to get a job is not a good reason to be here, right? I get this a lot, so I do a lot of mentorship, and it's like, okay, what help do you need? And basically the whole thing is to get a job. One of the big things to understand as technology professionals is we get paid in a very weird way. You need to think about your paycheck over something like a decade rather than on a month-to-month basis, because that's the thing. Sometimes we get paid really, really well, and sometimes we're laid off for a really long time. But the thing is, like when you're laid off, you still need to keep increasing your skill set. So right now, we got a weird macroeconomic forces going on. It's gonna get worse. We've seen this crap before. But one of the problems is the people in the technology world is they kind of stop, right? Oops, I lost my job. I'm going to stop improving myself. But technology keeps trucking along. So if you get that amazing interview a year from now, but you haven't done anything, the thing is you may not be up to date with what the current skill sets are, and so you're not actually going to be valuable to folks. So that's where it's you really need to be thinking about like what kind of problems you want to solve for and actually go out there and build things. I was talking with a recruiter a couple of years ago, in Seattle. And one of his rules of thumb is whenever he was going to talk with somebody about trying to get them a job, he would literally go to GitHub. And he said 90% of the people, he knew the day that their boot camp graduated. Because you would see all of these entries to GitHub, and then it would stop. And literally, he would not meet with those people. He just did not care. Because these people they're not that interested in coding. So it's one of those things you need to be thinking about. Like, what problems do you have that you want to solve for? Again, when you think about like artificial intelligence, sitting down and building your own little projects. One of the weird things I've noticed, so I've been doing tech since 1996, is back with a lot of tech lessons, if you go back 20 years ago, almost everything was based around, now that we've taught you this, look at your environment, and figure out a problem to solve for. Oh, you've got a CD collection? Create a catalog for your CD collection. Oh, you've got recipes? Create a catalog for your recipe collection. Stupid stuff. But the idea was look at the problems that you have and then try to solve those particular problems. So it's going to be an important thing if you're going to get into the coding world. What problems does your organization have? So one of the big things I noticed is a lot of people don't want to actually talk with their bosses or their authority figures. There's like, oh, the authority figures or those people up there, I don't talk with them. They have problems like everybody else. And one of the big things to be thinking about is going and talking to the authority figures in your organization and asking them quite literally, what are the problems your organization has? Does your organization have a problem with hiring receptionists, right? So again, we're in a weird macroeconomic time where if you're in the wrong field, you're going to be laid off for 2 years. But if you're in the right field, there's not enough people, right? So like the receptionists, like it might be weird. Like coders are getting laid off, but you can't hire enough receptionists. So one of the things might be is you talk with your people in authority and say, okay, what problem is happening? And they say, we don't have enough receptionists to deal with the influx of calls that are coming in. And so that's where you can sit down and be like, oh, okay, well, I know Eli was talking about this Twilio thing and 11 Labs thing. Let me sit down and play for a couple of weeks and figure out if I can build a system that might be kind of some kind of automated receptionist type deal. And that's one of the things to be thinking about. And then also, if you're interested in technology and coding, like what vertical are you actually interested in? Are you interested in construction? Are you interested in interior design? If you're interested in healthcare? Again, that's going to be one of the things for figuring out the problems that are there and trying to figure out how you might be able to solve some particular problems. When you're thinking about what to learn, so we'll talk about stacks and languages in a little bit. But one of the big things to understand is any of these stacks, any of these languages are going to take about the same amount of time to learn. Learning PHP is going to take you about the same amount of time to learn as C#. Here's the deal, C# is going to pay you twice as much as PHP. So if you're going to take 6 months to learn a language, do you want to learn PHP, that's going to pay you, let's say $80,000, maybe $100,000 a year, or do you want to learn C#, that's going to pay you $150,000 a year? Exact same amount of work. It's just one technology is in more demand than another. That's one of those things you kind of got to think about. Oops. So things like earnings, and that's where you got to go out and you've actually got to talk with people. Again, go to meetups, talk with folks, see what is currently valuable. It was interesting. A couple of years ago, so there was a language and framework called Ruby on Rails, very popular about 2012 to 2015, and then it fell off for whatever reason. These things come and go. What was interesting is about 2022, 2023, there started to be more and more jobs for Ruby on Rails. And wait for it, the reason is because there were all of these projects that were developed back in 2015. Basically, they have had no maintenance for 5 or 6 years. And now all of a sudden these companies are like, oh, we need to upgrade, we need to do maintenance, we need to do all this stuff. And everybody has moved on from Ruby on Rails. So there's actually now Ruby on Rails jobs that there weren't for a little while. Again, that's kind of a weird thing to think about. One of the things to think about too is when you're learning the stacks, you're learning the languages, is the physical location for where you are. Now, this is interesting, right? So when I got my MCSE back in 2000, don't ask me why. West of the Mississippi, it was all Novell, and east of the Mississippi, it was all Microsoft. So there's something called Novell Networking. Anyways, Active Directory, all kinds of old stuff. But I went to a boot camp, and literally they had Novell and they had Microsoft. I was not smart. I just went, I know Microsoft, I'll do that one. And thankfully, that was what people were hiring for in my area. But it was a weird thing. Like if you went to California, they were like all Novell. I was in Maryland, they were all Microsoft. There's this weird thing where some places are just geographically, they care about certain languages. Again, when Ruby on Rails and PHP were around, more or less, those two languages solve the exact same types of problems. Ruby on Rails was easier to learn and easier to deploy, but it required more hardware resources. PHP, I hate to say, was harder. I guess it was a little harder than Ruby on Rails, but it was more resource efficient. Again, for whatever reason, East Coast really loved PHP, West Coast really loved Ruby on Rails. What language you need to learn really depended on where you were. I think about this with here being a research triangle. So a lot of people ask me about Linux and how to learn Linux and what Linux they should learn. And most people, 99% of the people on the planet, I will tell you learn Ubuntu. Learn Debian, learn Ubuntu. It's a great distribution. If you're research triangle, you actually have Red Hat. This is the one location in the world where I might be like, Red Hat certification actually does matter for you. And that's one of the things to be thinking about with any kind of these technologies. And then certifications. A lot of people ask what certification to get, and basically the big question is what does your boss need, or what do the people in your area, what are they actually hiring for? Again, one of the questions I get, I've done more IT stuff for the education world, and so what's really interesting is the whole thing like virtualization. Like Eli, and I've gotten this question 500 times for 500 people. What virtualization certification should I get? It's like, should I get VMware? Should I get Citrix? Should I get Hyper-V? And there's a few others. And the answer is always, what does your company use? Because that's the thing. If you get a Citrix certification, your company uses VMware, it doesn't really matter. The other thing, too, with certifications is talk with people in your area, especially if you want to be a programmer. One of the interesting things is I was interviewing a CEO of a development company a few years ago. And again, I didn't know coding certification. So I'm like, what's the MCSE of the coding world? And basically, he was really blunt. And he said, if he sees certifications on your resume, he won't hire you. And I was like, damn, that's kind of rough. And I asked, I was like, what? I mean, that seems weird. That seems overly rough. And he said, basically for him, what he said is, I need people to solve problems. If you're getting certifications, you are showing me what you think is valuable. And I find that to have zero value. It's like you can either show me a portfolio or you can show me certifications. If you're showing me certifications without a portfolio, I do not care about your resume. And so however you feel about that, this is not a place for argument over that. One of the things to be thinking about is the people that are hiring in your area. Again, if you're in an area that has a lot of government work, they may want certifications. If you're in an area that has a lot of startups or whatever else, they may actually look down on certifications. Something to think about. The next thing to consider when you're thinking about programming or anything else in the technology world is you do not marry a stack. You marry a spouse. I'm married to my wife. I love my wife. I'll be with my wife till death. I will not be that way with programming languages. I used to flirt with Visual Basic, and then I did stuff with PHP, and now I screw around with Python. That's what a stack is. Stacks come and stacks go. One of the big problems that I see, especially with a lot of young people, is they're like, I've got to figure out the perfect stack. And so they'll spend 6 months figuring out which stack they should learn. And again, instead of learning a stack, they're figuring out which stack to learn. The important thing to understand is all of these stacks, more or less, are the same. Again, if you're learning a programming language, they all have if-else statements. They all have loops. They're all going to do API calls. They're all going to connect to databases. They're all going to do all that kind of stuff. So the information that you're going to learn about one does transfer to another. So sit down, talk with people, do a bit of research, place your bet, and then start learning. Right? And as you learn, you might find out there's a better direction to go into, but you don't have to marry your stack. Again, it's really interesting. I tell people, I teach Python or teach PHP or whatever, and it's amazing how people just lose their mind sometimes. Again, professionals are weird. They will just start dogging me about teaching a particular language. Well, you should be I'm like, guys, it's a free class. I'm teaching people the but there's this idea like JavaScript is the best. It's like, yeah, for some solutions it is, but not for everything. Oops. Let's see here. Go to page 4 and 5. One of the big things, you'll hear that I hate node developers. That is true. Again, it's my opinion. It's my opinion, but I'm going to be honest with it. One of the big issues you get to nowadays, especially if you're young, is we have this whole debate me bro culture, which is really weird. I miss the old days of being a tech professional. So I've been doing tech since 1996. I'm a Gen X tech professional. None of us wanted to grow up to be tech professionals. That was the thing. We were all doing something completely different. And then we all had these very weird stories about what landed us into the server room. The issue that you run into in the modern world is a lot of people, and this is what I get worried about with a lot of young folks nowadays, is if you don't have family, and you don't have community, and you don't have religion, if you're not being of service to the community or have served in the community, whether it's military or missionary work or Peace Corps or whatever else, if all you have is your stack, there are a lot of people out there, the only thing of value in their life is they went to a boot camp, they learned JavaScript, and by God, that's what makes them important on this planet. Oh God, when you run into these people. Because you'll just be talking with people, and they will just start hammering the hell out of you. Again, identity politics or whatever else. Honestly, I will come back from events, I will come back from conferences and business meetings, and I will look at my wife sometimes and I will say, dear, I'm almost 50 years old. When does this shit stop? When do I stop getting mansplained? And you can't even get a word into people. And so this is one of those things just to be thinking about. So when you go out and you're talking with people, take advice from people that listen to you. If you say, I am trying to create a front-end solution that's going to deal with 1,000 users per hour, and I'm planning to use PHP, and they go, PHP, really? Right? Listen to them, right? Because they listened to what your situation is, they listen to what you're trying to build, and they listen to what your outcome may or may not be. And again, who knows? Maybe Node is a solution in that particular situation. But a lot of times what's going to happen is you're just going to say, I'm developing an X, Y, or Z, and they are just going to dog you. Again, I have a buddy of mine who very successful, incredibly successful dealing with a very old programming language. And it was amazing to go and see JavaScript developers dog him about the whole idea of the sunk cost fallacy, right? They're like, oh, well, your customers, your clients, they need to upgrade, sunk cost fallacy. And I was like, yeah, you don't know how much he makes. He's doing fine in life. If there's somebody that needs to listen, you need to be listening to him, right? And that was the funny thing. Like, he'd talk about it. He's like, look, I don't have any control over what they upgrade to. Like, this is the system they want maintained. This is the systems I maintain. They hire me for a lot of money. Why am I going to do something else? So something to think about there. If you're going to be learning, one of the big things that comes up, especially a lot of folks that I've mentored, is they want to learn a lot of things, right? There's this whole idea, I want to learn everything in computers, I want to learn everything in technology, everything in AI. You can learn one thing at a time. Focus on one thing at a time, learn that thing relatively well, and then branch out from there. One of the big things that's kind of come up, especially in the artificial intelligence world, is there are a lot of technologies. It's really interesting. So there's something called MCP protocol. It's Model Context Protocol. It's a way for designing agents. One of the things 6-7 months ago, it's where everybody was going. Everybody was MCP. What's kind of curious now is a couple months later, now people are like, I don't really like MCP anymore. They're going in a bit of a different direction, right? So one of the things is you have people that get really focused on trying to learn everything at once, so they don't learn anything particularly well. And then especially with artificial intelligence, they start chasing all of these dead ends. Like, by the time you learn anything, it's already going to be a dead end, and they kind of get nowhere. So that's where, focus on Python. So if you're going to, again, from a lot of artificial intelligence stuff, focus on Python. When you've learned Python, focus on how databases work. When you've learned how databases work, then start learning about how to integrate artificial intelligence in, and then thinking about, again, how do you want your data stores to be set up? How do you want RAG to work? That type of thing. Let's see here. And the final part on all of this is that there is no right answer in technology. Again, one of the things people get fixated on is this idea of this is the language you need to use. As I will say, if you hire me, you're not going to hire me. But back in the days when people would hire me, if you give me $1 million, right, if you're like, we need an AI solution, and you hand me $1 million in resources, I will build you an amazing AI solution. If you say I need an AI solution and you give me $20, you're going to get a Raspberry Pi with Granite 4 model on it. Again, whatever resources you give me, I will give you a solution. But it depends upon the resources, and that's the kind of thing that you need to be thinking about. Again, what is the legacy architecture? What are the resources? What are a lot of these other things? And basically build and learn based off of that type of stuff. Any questions on that part? Yep.
Yeah, so talking about like not trying to marry stack. So you're saying like yeah, don't try to like don't get too attached to like say Python or JavaScript. What about like learning like design patterns that you can like kind of implement or like that you can implement like between different languages?
So yeah, so the design patterns is basically like how you build things. Yeah, so those will probably be more or less the same amongst all the different languages. So again, and that's what I say is like there's a skill set that you'll learn. So like if you learn how to do wireframing properly, wireframing whether you're doing PHP or iOS development or Android development, wireframing is going to kind of be like wireframing. So those skills will remain more or less the same. It's the programming languages, those types of things that change. Yeah. Okay, so we get to education. So how do you want to learn this stuff? So I used to poo-poo in-person college a lot. So again, if you watch my videos from 2012, I crapped on in-person college. Look, I have a college degree. I can crap on it because I got one. It's pretty crappy, to be honest with you. The interesting thing I found, and I think this is going to be a bigger issue going forward, 2026 forward, is there's a lot of people out there, you don't really know what you want to do. You don't really know what direction you want to go into. You don't really know what tech stack you want to work on. You don't really know what the hell a tech stack is. You're like, tech stack, yeah, you like it. No, you don't. Anyways, which is fine. One of the things that I'll say with in-person college is it actually gives you 4 years to figure out what the hell you want to do. One of the big problems that we run into with people that get into the technology world or try to learn this technology is they try to learn it really fast and then they try to get a job. And again, your career is going to be a long time. Your career is going to be decades. And a lot of times when you try to do things too quickly, you're just going to kind of trip over yourself. You're not really going to get anywhere. The nice thing about college is you're able to get into an environment. You're able to be around other people. You're able to hear what other people are doing, what job opportunities there are, that type of thing. And that can be very valuable for you. Online college. So again, it's 2026. If you're in a position to actually be able to get a job, online college is fine. I've talked with many, many recruiters, many, many HR people. They don't give a crap about online college anymore. It's not 2006, it's 2026. That is a fine certification. The problem that I see with people that get to online college, though, is again, if you're in your own little world, so if you're here in Research Triangle, you're in Research Triangle, you are a consultant or whatever, you're helping people code, you come to meetups, you talk with people, you do education, online college is fine. One of the big problems I see though with a lot of folks that get into online college is they learn a lot, but then they don't really know when to stop. I literally had one of my viewers, I did this meeting with him, and he was like, yeah, Eli, I have my bachelor's degree in IT. He had his master's degree in something like cybersecurity, plus he had a couple of other certifications. And he's like, yeah, Eli, what should I do next to get a job? I'm like, dude, get a job. Just get a job, right? But the problem that you get into with a lot of like the online colleges is people get used, that becomes the work. Getting the degree, going to school becomes the work, and you actually lose the connection with the idea of how do you get a paycheck. And so one of the things with online colleges, again, they're absolutely fine if you kind of understand the path that you need to go down to turn that into work. It can be an absolute dead end though. Again, I do worry, like I'm from Asheville, out in the boondocks. One of the problems, the things I get concerned about with people out in the boondocks doing online college is you're out in the boondocks, you get this degree, and again, who's hiring for you? Right? Who, again, like I drive 3.5 hours to do these classes because I get this many people to show up to my classes here. I do this same class in Asheville, and as I say, I'm willing to teach 3 people, but I prefer to teach more than that, right? And that's the thing, like you get this education and there's just no jobs around you. Boot camps. Boot camps can be absolutely great. One of the issues that you run into, though, is that they're very expensive. Many of them could be, again, $20,000, as much as a college degree can cost in some places. And people get accelerated out. And the issue you can run into with boot camps, if you don't get into a job or if you don't keep refining your skills, your education atrophies. So you're in this boot camp. You're like, I'm going to learn this in 3 months. I'm going to learn all this information, which is sort of true. The problem is like every week you're out of that boot camp, you literally lose information. Information goes out of your ears. So if you go through a 3-month boot camp and you learn all this stuff and it takes you a year to get a job, you're basically going to be back at help desk level. And so that's one of the things we think about these boot camps is they're an accelerator, but the idea is it needs to accelerate you into a job. If it kind of just accelerates you into the parking lot, it's probably not going to be nearly as valuable as you think it is. The other thing to realize with the boot camps is they're going to teach you a whole stack, which is actually a good thing, right? So they're going to teach you the JavaScript stack or the iOS stack or whatever else, basically how to develop more or less an entire product. The other thing to be asking is, in your area, are people hiring for that particular stack? Again, if you learn iOS and people in your area no longer really care about iOS, you're going to run into some issues there. Certifications, again, as I talked about before, certifications are great for learning a single product. One of the big questions is, does anybody in your area care about that particular product? That's going to be a question. And then self-study. Self-study is terrific, again, as long as you know what direction you want to go into, right? So you're like, okay, I've learned all this stuff about Python. I need to understand more about databases. So I'm going to go and self-study on Postgres or something like that. That is absolutely perfect. But again, you're going to need to know, like, why are you learning this? So Postgres is a database engine. And so if I tell you, you should know Postgres, you're like, okay. And you go out and you learn Postgres. If all you know is Postgres, it's not really going to do that much for you. Again, if you understand Python, you understand how to build a web application, and you want to use Postgres as your record store backend, then Postgres is going to be amazing. If you just learn Postgres. I talk about this with way back when, so I got my MCSE. I decided I want to learn how to code back in like 2001. So I got a C++ in 24 hours book. And I took that. And I learned how to make class cat because it was C++, and I dealt with C++. Oh, unless somebody actually teaches you C++, so you're building things from a practical standpoint, a lot of the C++ you learn is very, like, they teach you C++, but literally you get to the end of 24 and you're like, I was in MCSE literally building networks and building servers, and I didn't know what the hell to do with the information that I just learned. And so that's where I always say, I know how to create a class cat in C++. So be careful about that. When you start building things, again, whether it's going to be coding projects or it's going to be artificial intelligence, there's a lot of considerations to take into account. One of the big things to be thinking about is the institutional knowledge, right? So this is going to be big with artificial intelligence and vibe coding. So what institutional knowledge is not what you know. One of the big problems we have in the modern world is everybody's like, I am important. It's like, good for you. We don't care about you, right? In the organization, in your institution, we care about the entire team, right? It's what the team knows. So you can be an expert on Java, and you can be an expert on C#, and everybody else can know Python. Guess what we're going to build on? Python, right? One of the big problems you run into is people say, well, I'm responsible for this project, and I know this language, ergo, I'm going to build this. One of the things you have to think about is what happens if you fall over from a heart attack? Will somebody be able to pick up your project and be able to maintain it, again, relatively decently? And when I talk about that, you're like, oh, heart attack, that's melodramatic. In my little tech community last year, fuck me, one of our guys, I saw this thing on LinkedIn saying condolences, and I had seen him the week before, and I was like, what the hell happened to him? It's like, oh, he fell over from a heart attack and died. It's like, crap. And about a month before, we had another guy literally had a heart attack. He did not die. Once you start getting over about 40 years old and you're male, I'm just saying you might want to start running and eating some more oatmeal, right? Falling over from a heart attack is a real thing. And so that's one of the things you need to be thinking about. It's like, what is the institutional knowledge? Again, you start thinking about vibe coding. You start thinking about auditing, right? So imagine you have a vibe coding platform, you build something, and it builds some amazing platform in Rust. So apparently Rust is cool. I don't know, I looked at it, made my brain hurt. Anyways, so let's say it builds this amazing platform in Rust. Do you have any employees on your team that can actually audit Rust? Very important thing to think about. The next thing to be thinking about is for your organization is resources, both short and long term. That can be a problem, right? CEO, C-level executive says, we need to build something. So they throw a lot of money at you. That's great. Question is how much money are they going to keep funding you at, right? So again, you might run into a problem, might run into an issue where they're like, here's $1 million. And then you build the thing, and they're like, okay, we're done with that. You're like, no, but we still need $100,000 a month to keep this damn thing running, right? One of the things to question is like basically what resources, short-term, long-term, things like beyond money, what servers do you already have in your data center, right? Again, when you start thinking about do you go onto the cloud or do you local, what you might find out is they procured 20 20 servers too many for the last project, and so you've got 20 Xeon servers just sitting there literally doing nothing. Like, oh, look, that's $50,000 in servers. Might as well use that for the project that we're doing. Again, this is one of the things you need to be thinking about with actually talking with people. Another big thing is total cost of ownership. So this comes up big, kind of like in the Linux and the Windows world. So again, all the 18-year-olds are out there are like, Windows is stupid. Everybody should use Linux. It's like, you have never dealt with total cost of ownership. Total cost of ownership is what is the cost of this project going to be over its lifespan. So when you think about Linux, Linux is free. Linux is free, right? You don't pay for a license. Windows is going to cost you $600-800 for the server license, plus these things called CALs, client access licenses. It starts raising in money. One of the things to be thinking about, though, like with the Windows world, is almost everybody knows how to administer Windows. Like figuring out how to administer Windows is a pretty simple thing at this point in time. MCSEs now have been around for 30 years, right? So if your Windows systems goes down, you can swipe a credit card and you can repair that problem. If you have Linux systems of all kinds of different flavors, because this intern like Ubuntu, and this intern like Fedora, and that intern like CentOS, and so you've got a whole bunch of different Linux systems. When there's a problem, all of a sudden you have to find somebody that has the technical expertise to actually be able to fix that problem, and that might get very expensive very quickly. And so that's going to be one of the things to be thinking about when you're building your projects. Again, artificial intelligence or coding or whatever else. As I said before, the thing to be thinking about is PHP people are cheap. Again, in the Asheville area, PHP people make like $40,000, $50,000 a year, and they're pretty happy with it, which is kind of weird. Whereas again, no developer is going to make $150,000 a year. So if you're creating a relatively simple web app, so there's something called curl. We'll talk about that in actual technical classes. But basically with curl, you're able to interact with a lot of these AI services, basically just through kind of like a URL call. And so you can literally build a PHP app that has a lot of artificial intelligence services built into it. And depending on what you're actually trying to accomplish, it might do everything you need it to do. And again, you can basically pay peanuts for the developers that are doing it. That's one of the things you need to be thinking about. Party buy-in, this is going to be one of the big things, is talking with the vested interests and figuring out what people are willing to pay for and what people actually want. Again, you'll notice, again, as a technology professional, I talk about talking a lot, and that's one of the things you're going to need to do. You're going to need to talk with a lot of different people to figure out what the hell they actually want, and also to get their buy-in. Right? That's the thing. Like, if people trust you, then they will just say yes. Like back when I had clients back in the day, they would say what they wanted. They would say, I want this thing. And I would look at them square in the eye and say, that's dumb, right? I'm the professional, you're hiring me to do this, and I'm gonna tell you, it's dumb, but you're my boss. You're the boss. If you tell me to do it, I will do it, right? And I would do it, and everything would blow up. They're like, crap, you were right. I was like, yes, I was trying to save you a lot of money, a lot of time, a lot of frustration, but you're the boss, so I did it. And the amazing part was after that, every damn one of my clients, I would say, I think this is what you need. And they're like, sure. And then I was like, wow, really? And they're like, look, I told you to do something before. You told me not to do it. It blew up, right? And so that's one of the things you need is the buy. You actually need trust. It's amazing. Like I talk with a lot of technology professionals nowadays, and there's this whole idea of like, I don't want to do office politics. I did not get into coding to do office politics. But here's the deal. If your CEO likes you, you're going to get your shit. Like the CEO, there's all of these decision points people have to make, and we'd like to think it's all reasonable and rational and all based on profit loss statements. A lot of times you have really tired executives that just need to keep the ball moving in a particular direction. And you know what? Every time you've told them something, it's turned out to be true. You need resources. Take the resources. They want to win as much as you do. So that's one of the things to be thinking about with buy-in. The other thing to be thinking about with all this kind of stuff, especially with artificial intelligence, and again with really AI, is tech the best solution for a lot of stuff? One of the things you see, again, in the real world of business is you're going to have workflows, you're going to have employees doing things. Many times, technology just actually isn't the best solution. Maybe it might be a brown bag, lunch where you teach people how to do something better, right? Do you need a better system to do things, or do your employees just need to understand how the current system works better? Something to kind of consider there. One of the things to be thinking about, especially with artificial intelligence, is things like the definition of speed. So you'll hear this a lot. So C++ apparently can add up to 1 billion really quick, I've been informed. Python apparently adds up to 1 billion really slow. Here's the thing. Does your code need to add up to 1 billion? That's one of the questions, right? One of the big things to be thinking about with development, again, when we start thinking about putting stuff into production, you'll hear this about Rust. Rust is a much faster language than many other languages. But one of the questions you need to ask yourself is you've got speed, the speed that your platform or product will require in order to provide services to the end user, but there's also the development speed. Right, again, when you think about things like Python, Python is a relatively easy to learn language. It's relatively easy to get people up to speed. A lot of people know Python already. So Python might theoretically be dirt slow, theoretically. But again, if you're just creating a web application, if you're creating an application where people are going to be asking questions, it's going to be going to an AI system, bringing a response back, doing stuff with that, you don't need to count to 1 billion really quickly. So again, that's one of the kind of things that you need to be thinking about with these programming languages. If you're dealing with things like computer vision, though, again, it depends on what level you're dealing with. So there's something called the OpenCV. It's a computer vision framework. So if you're using the framework as it is, you can just use Python in order to connect to the framework in order to get a lot of computer vision functionality out of it. The thing is, if you're going to start doing more sophisticated things with computer vision, that's where things like C++ can be more valuable for you because it actually can run faster. Those are some considerations there. Let's see here. Regulations and laws. This is going to be a big one. Things like HIPAA, PCI, data sovereignty laws. Data sovereignty is going to become more important. Again, when we do Silicon Dojo, I'm going to try to stay the hell away from politics. Unfortunately, politics is the modern world. So data sovereignty, the idea is a lot of countries out there don't want their citizens' information to leave their country. So one of the big things to be thinking about is if you're going to be using somebody's services, even if it's a company from a different country, a vendor from a different country, if they have a data center in your country, that might be okay. But one of the problems you run into, and again, where you have to understand how technology actually works, is I did an interview with the managed service provider CEO for a company in Canada. And so he was talking about not using Azure. So all of he's a managed service provider, all of his customers are on the Microsoft stack, he fucking adores the Microsoft stack, he has nothing technically wrong against Microsoft. The reason he doesn't use Azure is because Azure has a data center in Canada. The thing is, for resiliency, data centers replicate their information for this infrastructure as a service somewhere else so that if a tsunami takes out one data center, not all the data is lost. They've got one data center in Canada, which means all that data gets replicated somewhere else. And Azure, Microsoft, will not explain to him where that data is getting replicated to. And so in the modern world, again, there starts to become some legal questions there. And this is the kind of thing to be thinking about. Again, if you're HIPAA is for healthcare information, PCI is for things like credit card information. Again, things to be thinking about if you're using these AI systems, right? Do you use OpenAI? Do you use a local system? Do you obfuscate data? So obfuscating data isn't necessarily where you encrypt it. You just kind of change names, you change things, right? So if you're looking for pattern recognition, do you send the clean data to OpenAI to find the pattern recognition, or do you obfuscate the data in some way? Change names, change different information. So it's like, oh, whenever 5 dogs are walking in the sun, that means 6 cats are asleep. Again, you might come up with some kind of codes for your own information so that OpenAI isn't necessarily learning from your stuff. Again, these are some of the things to be thinking about. And again, with these laws and regulations, they're only going to get worse. I would argue, again, if you really want to be a disruptor in the modern world of technology, get your MBA or your Juris Doctor. I'm telling you, lawyers are going to have more to do with the technology world for the next decade than technology professionals are. And then scalability. This is going to be one of the big things, is again, thinking about how your code and how your project scales and what the cost of scaling is going to look like. Again, what's your institutional knowledge? So we talk about things like local infrastructure. If you're going to have local infrastructure, it can be very, very valuable, but do you have people to support your local infrastructure, right? So if you're going to deploy 2 servers, what happens if the CPU fan fails in one of those servers? Who are you actually going to be able to call in order to get that fixed? Again, that's one of those questions you have to think about. Any questions on things like the considerations for your projects? Yeah, thumbs up. Cool. Okay, so then we get to project management. Fun stuff. So everything we're talking about tonight, again, are little snippets. We're going to have many, many classes. So basically project management, we're talking about this. Generally, we're talking about the waterfall style or the agile style of project management. And this is going to be something to be thinking about when you start pitching your projects or when you start working on projects for your bosses or for your clients. So waterfall, the waterfall style of project management is the old school way of doing tech projects. Basically, the idea is you know what the problem is, you pitch a solution, they agree to the solution, you deliver the solution, you get cash, you walk the hell away. That's basically what a waterfall is, right? So basically the idea is a customer or your boss comes to you and says, this is the problem that we are having, right? We need to be able to store files on the network. We need, again, with artificial intelligence, we need our sales agents to be able to ask questions of an AI system to be able to get responses back or whatever else. And so basically they come to you with a problem. So once they come to you with a problem, what you're going to need to do is you're going to need to fully define what the hell the problem is, right? They tell you what the problem is, but then you've got to spend the next 3 weeks actually figuring out what that really means. It's kind of like Socratic method. So if you haven't read Plato or Socrates, I would highly recommend you do if you're going to be in the technology world. The idea with Socratic method is somebody says, I want artificial intelligence. And you say, what is artificial intelligence? And they say, I want a system that is able to think. And you're like, what is thinking? And then you go back and forth to figure out what the hell they're actually talking about. Again, it actually is important. Anyways, you go through and you figure out exactly what the user wants. You figure out what resources, again, money, legacy systems, all of that kind of stuff that are available. You create a plan, Gantt charts. Those are beautiful. I miss Gantt charts. Gantt charts that go across entire walls. I just miss those. Anyways, a Gantt chart is this project management chart. Shows all the different tasks that have to be accomplished. Anyways, you go through that chart, you check everything off, you get the client approval. At some point, you actually deliver the product to the customer, and they give you a check. One of the big things to understand about waterfall project management is that there is an end. There is an end, right? There's maintenance, there's upgrade, there's that kind of stuff. But more or less, they pay you $100,000, $1 million, and then, they pay $1,000, $2,000 a month to keep the system up and running for feed and watering. But the idea is there is a project and that there is an end. So Agile is the modern way, especially in the coding world, of building stuff that is either amazing or ass stupid, or how you're going to get rich, basically. And what Agile is there is no end. It just keeps going forever. Like, it's kind of funny. Like you use platforms like Twitter or Facebook, or I use YouTube, and really they could have stopped a decade ago. Like if you look at most of these platforms, like they offered all the services we all needed about 10 years ago, and they could have stopped. But the thing is, with Agile, the concept is that you create basically something like a minimum viable product. You create the minimum product that's required to actually start providing services to end users. And then you deploy that, and then you start seeing what the problems are, and then you start getting feedback from the users. And then as you get the feedback, then you start making changes. Again, some platforms, you'll literally hear about them making 100 changes per day, just continuously doing this infinitum. And basically that's the idea, is that you're constantly changing, you're constantly keeping things up to date, and the idea being is that there will never really be an end. So depending on what you're doing, this can be good or bad. I've seen this in the real world with development companies where their customers don't understand this concept. They think it's going to be waterfall, they think there's going to be an end. And then after the customers literally spent $1 million, they realize this never ends. And that can be a bit of an issue. And so that's one of the things to kind of consider, like when you're building these projects, is basically when is the end? Are there going to be resources? Is there going to be money to continue this project forever? Or at some point, are you going to have to wrap this thing up? So again, there's going to be preventive maintenance and things, but it shouldn't be a continuous outlay. One of the big things here is client expectations. What I used to tell my employees, and what I'll tell all of you, is professionals. How you can tell a real professional at the end of the day? A professional answers the questions the customer does not know to ask. If you say the customer did not ask, bite me, you're a bastard. Like, I'm just going to be blunt about it, right? Because so many people use that as an excuse. The customer didn't ask that question. Like, dude, the customer's the florist. They don't know what a firewall is or a gateway is or encryption is. They came to you for an email solution. And just because they didn't ask the question, that's not good enough, right? And so that's one of the things you need to be thinking about when you start talking with your boss or whatever, is again, it's that whole communication, like how long do you want this to go for, so on and so forth. Okay, so now I get to some of the actual programming stuff. So programming languages. Are people going that way to the bathroom? I guess there's bathrooms that way. Anyways, so when we start talking about programming languages, people ask, like, what programming language should I learn? The big thing to understand is basically programming languages is they're more or less like programs, right? You can write a term paper on QuickBooks, and you can create an invoice on Word. That is a miserable way to do things. Same thing is true with programming languages. They are built to do specific things, right? So if you're talking about PHP, PHP is designed to build dynamic websites. Basically, they'll be hosted on Apache or an Nginx web servers with some kind of database backend, most likely MySQL, right? So basically, PHP allows you to very easily build dynamic websites, something like Craigslist. All right. On the other hand, if you want to build iOS apps, so you want to build an app for your smartphone, that's going to require Swift. So Swift is a programming language for Apple devices. C#, so we talk about stacks. If you're going to be building on what's called the Microsoft stack and you want all the resources that are available on the Microsoft stack, you would use a programming language like C#, or basically you use C#. And so one of the big things to be thinking about, again, with these programming languages, again, we go back to that whole thing of what problem do you want to solve, what resources do you have, what environment are you going to go into, and that's one of the ways you figure out what programming language you're going to use. When we talk about interpreted programming languages, again, are going to be Python, they're going to be PHP, they're going to be Ruby on Rails, going to be other languages like that. Basically what you have with an interpreted programming language is you have a text file. So this is just UTF-8 or ASCII text file, and then you have an interpreter that is installed onto your computer, or needs to be installed onto your computer. And again, that's one of those things you have to be talking with people to make sure crap is actually installed on systems. Because like what's really interesting is Python is an interpreted programming language. With Python, you can create GUI applications. So you can actually create applications with boxes and all that kind of stuff, right? Just normal GUI. It's something called tkinter as a framework. The thing is, for that script to run on a system, Python 3 actually has to be installed. Python 3 is not necessarily installed on every single computer out there. So you can create this really cool application using Python 3 and something like tkinter. And you're like, look at this great GUI application. Just tell all of our employees to download this and run this, and everything's going to be great. And they're like, well, it's all failing on 99% of the computers because nobody has Python 3 installed. So how are we going to get Python 3 installed onto these systems? And that's where you talk with people like systems administrators to get that done. So anyways, when you're talking about interpreted programming languages, with the interpreted programming language, it is actually an application that is installed on your computer. The important thing to understand about that application is it has versions just like everything else has versions. So Python, again, what we use. There used to be Python 2. Do not worry about Python 2. But there's Python 3, and you'll hear about Python 3.8. You'll hear about Python, I think it's currently 3.14.2. One of the interesting things is a lot of like the AI services. So there's modules in Python. Anyways, a lot of those modules will not work with Python versions that are less than 3.8. So if you have a lot of computers that were deployed, let's say 8 years ago, because computers last a long time now, they have Python installed, but it's 3.5. You go to ship out your code, again, some kind of GUI interface, then you're going to run into a lot of problems. So that's what an interpreted programming language is. You then have compiled languages. So when you're dealing with Linux or you're dealing with Windows, sometimes Mac, I guess. What a compiled language is basically you create all your code, and then you run this through a piece of software called a compiler. And so the compiler then turns your code into an executable. It actually turns it into machine language so it can run directly on your system. The idea why this is better than interpreted language is you don't need the interpreter, so the interpreter goes away. As long as your Windows works, and you compiled for Windows, this application should work, so that's a good thing. And generally it's considered faster. So again, if you're playing things like video games, it's modern computers, it's 2026, but it's faster. It is faster. So that's one of the reasons you go for compiled programming languages. One of the issues with compiled programming languages, though, is something called porting. So you compile a program for each operating system that it will run on. So if you take your code and you run it through a compiler for Windows, you will now have a Windows application. That Windows application will not work on Linux. And here's the thing, a lot of the stuff that will work on Windows also won't work on Linux. So the idea with porting is where you rewrite your code and send it through the compiler to work on the different operating systems. And so that's where you'll see, again, if you go back about 15 years ago, it was interesting, like with Mac. If you were on Windows, QuickBooks had 15 versions that you could use, right? They had the pro version, the basic version, the contractor version, the nonprofit version. They had all the versions on Windows, right? You go to Mac, you had one version. And basically what they did is at that time, you had to port the program to these different operating systems, and they looked at the resources, and they said 1% of our users are on Mac and 99% are on Windows, so we're just going to, basically have everything just simply run on Windows itself. So that's a compiled language. You then get to runtimes. So normally hear about Java and .NET. How much you hear about these anymore? Right, you used to hear about these a lot more about 20 years ago. Basically with a runtime environment, what happens is you install the runtime environment onto the computer. So there's, like for Java, there's a version for Mac, there's a version for Windows, there's a version for Linux. Basically that gives you a foundation so that you can write code that will run on any of those operating systems, as long as the runtime is installed. So kind of the same concept as an interpreter, only it's not an interpreter, it's a runtime. It gives you better performance, it gives you a little bit more functionality, but you do have to have that runtime installed. It's one of those things to kind of consider there. Again, when you're taking a look at languages, there's just so many. There's Python, JavaScript, C#, PHP, Java, Swift, COBOL, RGB. There's a lot of different ones out there. Again, which one you're going to use depends upon your environment and all that other stuff that we talked about previously. The next question that comes up is, what language do I need to learn? Because that's what everybody wants to know. What language will get me a job? It's important to understand it's probably not going to be one language, right? So for Silicon Dojo, when we are building projects, there's a lot of stuff going on. So it's not too complicated. You got HTML, right, to build the foundation of a web page. You have CSS, you have JavaScript, you have Python, and you have SQL on top of understanding Linux. So theoretically, as far as languages go, even for someplace as simple as Silicon Dojo, what is that? 1, 2, 3, 4, 5, 6. You're probably going to learn more than that too. So, you just need to know about 6 to actually be able to build something useful. And so, again, that's going to be one of those things to be thinking about with what problems are you going to solve for, right? So SQL is called structured query language. This is a language for what are called relational databases. So if you're going to need the services of a relational database, you're going to need to learn SQL. If you don't need a relational database, you don't need to learn SQL. That's basically how all this works, right? It's basically what are you building? Oh, let's see here. Any questions up till now? No. Easy. Oh, okay, what is that? Holy crap, I've been talking a lot. Okay, I talk. Anyway, let's see if we can go this a little faster, I guess. So what are tech stacks? We start talking about technology stacks. Basically, this is going to be all the technology that is required to actually be able to deploy a product. So back in the days, we used to have the Windows stack and the LAMP stack, and life was really easy. When we talk about LAMP stack, it was Linux, something called the Apache Web Server, MySQL, which is a database engine, and PHP, which was a back-end programming language. So that was LAMP. There was something called the Windows stack. So it was IIS and Microsoft SQL and all that Windows stuff out there. So it used to be Windows or LAMP back in the old days. Nowadays, oh my golly, oh, there's so many stacks. I was watching this one video on YouTube. There's a channel called Fireship. Watch Fireship. They have really good videos. Literally, holy crap, he had this one video, and it literally was the 30 most popular database engines. I was like, what the fuck? So again, which database are you going to use? Apparently, there's at least 30 to choose from nowadays. And again, and that's where I talk about like talking to, figuring out what your environment has and your institutional knowledge and all that kind of stuff. So when we're talking about the stack, all we're doing is we're talking about all the technology that is required to deploy the particular product, right? So when we're going to be building, hopefully we're going to be building that AI voice over IP system in a couple of weeks. And so in that, you would need Linux, you would need Python, you would need Twilio, you would need 11 labs, and we'll probably use a SQL backend. So whatever you would call that particular stack. You'll hear us about stacks like, was it MERN? MERN is MongoDB, Express, React, and Node. Anyways, they've got all of these words nowadays. Go to ChatGPT and say, what the hell does this actually mean? Go learn that. When we talk about front-end developers, so we're talking about these stacks, there's front-end developers. Front-end developers are going to be the developers that actually build the UI, the user interface, and the user experience. Basically, when people come to your web applications, the front-end developers are going to be dealing with things like the JavaScript, the CSS, that type of thing. React is what's called a framework that allows them to create front ends for you. And so that's basically what a front-end developer does. You'll then have back-end developers. So that's where we talk about things like Python. So Python, PHP, Ruby on Rails, C# probably, are back-end programming languages. And so what these back-end programming languages do is they take the information that comes in from the user and then they do something magical to it. They dump it into a database, they parse it, they send it off to an API call, that type of thing, and then they send information back to the front end. So basically that's what a back-end developer does. When you talk about full stack developer, this is what I think everybody should be nowadays. You should be at a minimum, a crappy full stack developer. One of the things that I see very sad, like it's very interesting, having done this for 30 years, is we used to build everything. Like I used to go in and build my server room. Everything in the server room I owned. So everything from the Active Directory to the file sharing to the printer sharing, everything I owned. And so what was really nice is when I became a consultant, it was really easy because I could go to small businesses and literally I didn't say I do like printers. I could like literally sell them a solution. Oh, do you need VPN access? Right? Do you have remote salespeople that need to access your internal network? I can build a VPN solution for you. I can build these solutions. One of the issues that I see nowadays with the front end developers especially is they can build a front end. They're amazing at JavaScript. Like great, what can you connect it to? And the problem that you run into, again, we got macro forces going on in the employment world right now. If you get fired, people don't want to hire a front end. They don't want to buy a user interface generally. They want to buy a product. Right? Hey, I can build a custom CRM solution for you. Oh, I'll buy that. Right? There's a difference between that and just like a front end or a back end. And that's what I would say with a full stack is the idea is that you can build the entire stack, at least to some degree. You also deal with system administrators. Again, this is something to be thinking about when you're going to be coding, especially when we start talking about things like interpreted programming languages. Oh, there's nothing worse in the world to build something and then to tell the senior system administrator, yes, I need this installed in the servers. And they go, no. You're like, no, you can't say that. I'm like, I can say that. Right? So anyways, basically system administrators, they're going to control all of your servers. So again, and that's going to be the type of thing to be thinking about is what are they going to allow on their systems, right? You go and you say, hey, we need to upgrade Python on our servers. And they go, yeah, we've got 1,000 servers. I don't feel comfortable with the stability of upgrading 1,000 servers. So you're not going to get Python 3.14, you're going to get Python 3.12, right? That kind of issue can really come up. And then you have the database administrators. This is one of those things you might think about becoming. Apparently, a lot of Asians are making a lot of money being database administrators because it's funny. Again, here in America, we all want to do the cool stuff. We want to do the cool, sexy JavaScript stuff. Nobody wants to do database administration. So apparently, a lot of Asians come and they're like, how much money will you pay me? Like, oh, that's a lot of money. And they become database administrators. So basically what database administrators are, again, we talk about databases. When you deal with relational databases and large database systems, there's all kinds of clustering and there's read and write databases and master databases. Like real database systems are just this behemoth of a thing. So like when you interact with it, you're just doing this little SQL statement, select all from table, right? The back end of that mess can just be a huge, huge thing. So again, you've also got database administrators there. When you go to start coding, you'll hear about things called IDEs. IDEs are integrated development environments. Basically, here at Silicon Dojo, we use VS Code. And so basically all this is, again, we talk about programs that are designed to do specific things. All an IDE is a program that is designed to actually write code. Again, back in 2000, I started writing code literally on Notepad. This is a beautiful thing, right? So again, you got things like color coding here. Like, oh, this is an F string, this is how it should look. You have your file collection over here. Basically with an IDE, you'll be able to add extensions. So again, like with VS Code, there's all kinds of different extensions that you can add, things like SSH control and all that kind of stuff. And basically all we're talking about when we're talking about an IDE is this is going to be an application specifically designed for writing code. What IDE you should use now is probably VS Code. Almost everybody I talk to uses VS Code in the modern world. One of the big things to be thinking about, again, if you're trying to actually get a job or if you're going to be working with other people, is all the IDEs are going to be able to write code well. The issue that you're going to run into is standardization. So like when we do classes, I get people who ask me, can I use a different IDE? And as I say, you're adults. You can do whatever the hell you want. Here's the deal. I'm used to VS Code, so I'm used to what color codes are supposed to look like. I'm used to what squiggly lines look like what. And I'm also used to what VS Code misses, because VS Code does miss things, right? So if I have a class of 24 people and everybody is using VS Code, it's very easy to go behind people and go, oh, I understand that squiggly mark. Oh, I understand why that error isn't showing up, so on and so forth. You start using some of the other IDEs, they are going to be different. So again, that's one of those things you have to be thinking about when you're working on a team, when you're working in an environment with other people. Simply standardizing on something can be very useful. But basically everybody I know uses VS, like literally everybody I know across the board uses VS Code. It is something that Microsoft did incredibly well. It is free. You don't get charged ever for it. It's a nice little IDE. There are other IDEs out there if you want to play with them. Let's see here. Frameworks. When we talk about frameworks, basically these are ways that you're going to start extending your particular programming language. So again, you'll hear about things like JavaScript, and then you'll hear about React. Or I'll talk about Python, and then you'll also talk about Django. So what these are code libraries. Again, in the real world of coding, the real world of technology, we copy and paste. Again, 18-year-olds try to reinvent the wheel all the time. Actual professionals just copy and paste as much as possible. It's a wheel. I'm just going to use that, right? And so basically what frameworks are is there are some companies out there that they need to build things, and they will build these frameworks so that they can be more efficient at building things. So like what's amazing, like I hate Facebook, like Mark Zuckerberg, I can say very mean things about, but for the technology professionals out there, he's great. Like, so React actually came from Facebook, right? There's a lot of products that have come from Facebook and have been open sourced for the development community. And so React is one of those frameworks. They need to be able to build user interfaces more efficiently and more effectively. They built the React framework. They had it. And then Mark Zuckerberg's like, everybody else can use it too. So when we're talking about frameworks, we're talking about things that basically can extend your code. If we're thinking about the Python world, the things that we use, OpenCV is a framework that adds computer vision to your Python projects. So you can actually have your project see things, and you can use a couple lines of Python code to make that work. Django allows you to create very sophisticated web applications. So if you're trying to create the next Instagram or whatever, I do believe Instagram was originally created on Django. So it has user account creation, all kind of stuff already built into it. Tkinter allows you to build graphical user interfaces, right? So these are the kinds of things that frameworks allow for. One of the big things that I will tell you, though, is a lot of people think that learning the programming language is what's going to be hard, and then, they'll also learn the frameworks. Frameworks can be exponentially more difficult to learn than the language itself. Python is simple. Django made me lose my damn mind. Like, I got the point of Python in a couple of days. It took me a month to get my brain around Django with the anyways, we're going to have a class on Django and how they teach Django. I was just crying. I was just like, because I wanted to do a class on it. I was like, oh, yeah, we're just going to do a class on web applications. I'll just learn Django and I'll teach it. And like a month later, it's like, oh, I finally learned it. It was brutal. Anyways, so that's frameworks. APIs are going to come up, so application programming interfaces. What APIs are these are ways for your code to actually be able to communicate with other vendor systems. So this is going to be big in the AI world with things like OpenAI, right? So OpenAI spends trillions of dollars on their data center infrastructure for AI services. What's amazing is with your Python code, you can use basically 5 or 6 lines of code to connect to their infrastructure. Basically, you get 5 or 6 lines of code, you pay them fractions of a fraction of a cent, and you get all the power of them spending $1 trillion on whatever the hell they're currently building. And that's basically what APIs allow you to do. There's a lot of APIs. Again, we'll go over this in many of our classes. So things for like weather. Like this is something you need to be thinking about, like with artificial intelligence. When we talk about intelligence, what does that actually mean, right? So if you want to talk to your system and you want to be able to ask your system, do I need an umbrella today? Right? An LLM has no clue. But if you connect it to the Open Weather API, right? So we've done this in class before. So basically, there's one API that will give you your geographic location. So using your external IP address, it'll tell you where you're at. So you use this one API call, it tells you your geographic location. You take your geographic location, you then do another API call to Open Weather and say, what is the weather today? It will give you a response back to give you precipitation and temperature and all that kind of stuff. And then you take the query, do I need an umbrella today? Here is the weather forecast. And then your LLM can say, yes, you do need an umbrella. No, you don't need an umbrella, that type of thing. And so that's what we're talking about with REST API calls or API calls in general. A lot of cool stuff there. This is basically where your system is able to go out and communicate with other people's systems. When you're dealing with APIs, this is something called service-oriented architecture. And the idea with service-oriented architecture is that you basically do not own all of the services. So back in the old days when I started, again, NT 4.0, it's something called client-server architecture. We owned everything. We owned our Exchange server, we owned our file server, we owned our print servers, everything was ours. In the modern world, you go out and you connect to other people's services, right? So Twilio. So if you want to do voice communication, if you want to do SMS messaging, they bought SendGrid, so if you want to do email communication, again, with a couple of lines of code within your script, you can go out and communicate with that service. All right? So that's what we're talking about with APIs. We talk about architecture. So when you're thinking about these platforms in general, or you're thinking about building your system in general, again, with the front end, the back end, the system administrator, that type of thing, one of the things you need to be considering is what platform is this thing going to be running on? So again, like what operating system is your script, is your artificial intelligence going to be running on? Is it going to be running on Windows? Is it going to be running on Linux? Is it going to be running on some kind of Azure system? And then one of the things you also need to be thinking about is who is actually going to deploy that system. Like everybody gets really focused on the Python, everybody gets really focused on the code, but again, for your company, who's going to be responsible for the Azure account? Who is going to go into, again, if you've never used Azure, Azure has just gotten stupid over the past couple of years. There's so much, like they talk about that, like all these services. Like you go in there and there's like 200 services and they've all got all kinds of weird different control panels and figuring out who's actually going to go in and try to configure that so your code can run. Something to think about. Your overall infrastructure, again, to be thinking about where is this stuff going to reside? Is it going to reside locally? Are you going to have your own servers locally? Is it going to be up on Azure? Is it going to be something like a hybrid cloud environment? So a hybrid cloud is where some of the stuff is local to you, some of the stuff is up in the cloud. These are some things to consider. Things like file stores. Where are files going to be stored? Especially when we start talking about private information. Also, how is data going to be transmitted? So in Python, again, we do some of these AI classes. You can either transmit data using something called a URL. So you can have a publicly available file and just send a URL. And then the OpenAI grabs the file and deals with it. Or you can use something called Base64 and upload it. Well, one of the things to consider here, again, from a security standpoint, especially if you have an intern that's vibe coding, one of the easiest things to do is just make a public data store where all the files are just up on Amazon and they all have URLs and anybody can access the URLs. So you can just run a script and OpenAI can just grab anything that it wants and anybody else can also just grab any of that information they want too. Again, that's the kind of stuff you need to be thinking about. Let's see here, databases. So when you think about databases, there's relational databases and NoSQL databases. So relational databases basically are used when you really care about the accuracy of data and not losing any data, right? So things like inventory control systems, accounting systems, that type of thing. It's an acid system, atomic, consistent, isolated, durable. Basically, the idea is that when you're using a relational database system, no data gets lost. Everything is how it should be. The problem is with a relational database system is that it does take a lot of care and feeding, especially as you try to scale it up. So you start creating clusters of relational database systems, again, that type of thing. That can be very difficult. That's where you have NoSQL databases. And so basically with a relational database, you have something called a schema. And so what a schema is where you design the database from the get-go, right? So you have these things called tables. So everything is in a database, and then in the database are tables, and then the tables are records. So you have these columns. And so like the column is first name, last name, email address, age, whatever else. Well, the thing is when you start using a relational database, you initially have to design that schema. Again, that's where I go back to talking about the whiteboards and what we actually get paid for, right? So you sit there and you spend 2 weeks figuring out what the hell the schema for your system should look like because you never want to screw with that schema. There's something you can do. There's a command you can use called alter tables, which might not blow up your database. Maybe not. Make sure to back up beforehand, right? But the idea with the schema is you set this up and then you know exactly what data is going to be going into your database. A lot of coders don't really like that because that forces them to do work that they don't want to do, right? They want to go right into coding. And that's one of the things we have is something called a NoSQL database. So what NoSQL databases are, really cool, is they're schemaless. You basically just dump things in with keys and values. So you say, first name is this, last name is this, age is this, favorite art is this. I don't know, whatever information you want, you can just kind of dump it in there. What's cool about NoSQL databases is that they are incredibly scalable. You can just scale these things to the moon and back, and they're incredibly fast. The weird part about them is in it, they use what's called the base system, base compliant. Basically available and eventually consistent. So when you're using a relational database and somebody makes a transaction, as soon as that transaction is recorded, that is the same across the system. So let's say you have an ATM machine, right? If you have somebody that, let's say, has 2 ATM cards, they have $100 in their bank account. They take $100 out from this ATM. They can't go to another ATM and immediately pull that $100 out there, right? Because it's consistent across. As soon as a transaction happens, it happens. One of the interesting things with NoSQL databases is it's eventually consistent, right? You take $100 out of here, and at some point, the database system will understand that $100 is gone at some point. Basically, the idea with NoSQL is NoSQL actually changed the world. It's kind of funny. People talk about things like a blockchain, and they're like, blockchain is the database of the future. Blockchain is just a poser. NoSQL literally changed the world. This is the database system that was able to make social media work. Because basically the idea is with NoSQL, again, incredibly fast, incredibly scalable, and again, once in a while it loses data, right? Sometimes you put a transaction in, and it disappears. But that's the thing, is if you're dealing with Twitter, if you're dealing with Facebook, if you're dealing with LinkedIn, and you lose a post, if you lose 1 out of 1,000 posts, that's okay for the efficiency that you have and the speed that you have and the scalability that you get. You can't accept that out of some kind of like an inventory control system, right? So anyways, that's one of the things to be thinking about with NoSQL databases. Any questions up until this point?
Question on API.
Yep.
What's the cost looking like? Are we paying per query when our API is calling the LLM or something like that, or are we slapping this license key into the API?
So it depends on who you're using. So like if you're using OpenAI, so OpenAI now, let's say if you're using an AI model, so one, they've just got like 20 different models you can use, so figuring out the price can be really fun. But then after that is once you know what model you're using, then it will tell you. So it's actually impressive. I think it's the GPT-5 mini model, smaller model. Anyways, it's something like $1.50 per million input tokens, but then it's like $10 per million output tokens. So you can the idea is you can put a book in relatively inexpensively and then get like one sentence back. You know, they don't want to book out. Yeah. So it's basically whatever price they're charging. Yeah. Oh, since everybody is here, again, if you don't get pictures, it's not real. I always forget about getting enough pictures. Pictures. There you go. Anyways. Okay, so we did that for social media. Any other questions? No? Okay. Then we get to networking. So we will have a class on networking. But that's probably going to be one of the classes we have in February is TCP/IP4 for programmers. One of the things to think about, especially in the AI world, which gets to be really interesting, is there's this whole idea of pushing intelligence to the edge. So when we talk about the edge computing, basically these are the devices that are furthest out on the network. So think about the actual telephone itself. Think about the surveillance camera itself. Think about the access control reader itself. That's what we're talking about with the edge. So one of the interesting things to be thinking about once you start dealing with artificial intelligence is how you can do things like networking like a little bit differently. So normally you have TCP/IP version 4. This is where you have your IP addresses, you have DNS. We have a whole bunch of stuff we'll go into in a different class. But one of the curious things is, like I was talking about this before, where there's a company called Blues. Really cool if you haven't taken a look at it. BLUES. They have a square within a square as their symbol. What they do is they have these IoT communication cards, and with them, you pay like $60 for the card itself. The card lasts for 10 years and gives you 500 megs of data. And then what's really weird about it is it only communicates in JSON. You send information in JSON, you get information back in JSON. But what's cool is you can deploy these things anywhere. You can deploy these things on ships. They actually have a satellite version of it, so you can deploy it in Antarctica, whatever else, right? So one of the things to be thinking about, again, with artificial intelligence fundamentally changes how we can design systems. So normally, let's say we have a surveillance system. So you have a surveillance system, and basically you have a camera, and it has to send a video feed back somewhere. So again, if you're talking about a 1080p video feed, you're talking about 3 megabits per second per camera. So one, you have to get a connection that's 3 megabits per second to the video camera. And then, however many video cameras are coming back to your server, it has to be able to ingest all of that information. Right? So again, think about if you want to put a surveillance system in Antarctica or in the middle of the woods or whatever else. Wouldn't it be easier if you could do something like put computer vision onto an edge device and basically say, when you see a person, I want you to describe that person and then send me that text in JSON. Right? So imagine if you have a campus environment or a military environment or something like that. Basically, there should be nobody in this area. So let's say you're dealing with the military, and let's say you're dealing with an artillery range. Nobody should be on the artillery range for any goddamn reason. No reason, right? So imagine you put these relatively inexpensive cameras up, and basically all you want is if a human is seen, relay that back to a security center with a description of the person who's seen. Right? So you could deploy 1,000 of these within that environment. You don't have to worry about the massive network bandwidth that would be required for an actual video feed. And that's a way that you can have AI basically kind of abstract out the actual visual component from the alerting component, that type of deal. And so that's one of the things to be thinking about when you think about artificial intelligence and things like networking. Things like visual cues. Again, things like colors and lights and that kind of thing. Can you have lights go off kind of like with Morse code? And so one AI system can say, oh, that is the code for something, be able to do some interesting stuff. Something to consider there. Let's see here. We get to the basic development process when you're going to start writing your code. So the first thing to talk about is wireframing. So again, as I talk about, everything will be on the whiteboard. The most valuable thing in the world is the whiteboard. And I got this from ChatGPT. I said, ChatGPT, give me wireframes. So basically all a wireframe is, especially when you're dealing with some kind of front-end user interface that people are going to be using, is you literally just draw out what the hell you think you want the code to look like. right? Because again, as I've talked about before, the biggest issue that we run into is you talk to the customer, you talk to the client, they talk with you. You definitely know what everybody wants. You go spend 5 months building this thing, you show it to them, and they say, what the hell is this? I mean, this really happens, right? So one of the things with wireframes is literally with wireframes, you can sit there and you just simply draw out what the flow of the application is supposed to look like, what the dashboards, all of this kind of stuff is supposed to look like, and then you get the buy-in from the user to say, yes, this is what we actually want. So you can do this on pen and paper. Again, I would initially say when you sit down with your customer or your boss, just scribble this crap out on pen and paper to get an idea of what they're looking for. And then past that, there is software out there, such as there's software called Figma you might want to use. Basically, lots of different software out there depending on the size of your company that you can use to start professionally developing wireframes. The cool part about when you start using the software is there's sharing components, and you can actually have multiple people use the software at the same time, so you can kind of build things as a team. But this is basically what we're talking about when we're talking about wireframes. Do you have a question, or you just raise your hand? No? No. So past the wireframe, that's where you're going to draw everything out. The next thing to be thinking about is something called pseudocode. So it's weird how many people don't know about pseudocode, because it's really kind of simple. All pseudocode is where you type out in actual human readable format what you want your code to do, right? So a lot of times, and this is useful, especially in the ChatGPT world, a lot of times, like, you know what you want to have happen? Like, I want to select all the email addresses from a database where a certain value is X, and then I want to send an email to each one of those people. So that's what you know, right? You know you want to do this. But let's say it's a new programming language for you, or you're just kind of tired and you forget. You're like, crap, how do I do that in Python? Or how do I do that in C#? And so what you do is you take the pseudocode, what you've written out in actual human readable, and then you slowly go through and you build that up into what the actual code should look like. So pseudocode can be very useful, especially when you're new and you're writing code. You just put, so those hash signs are comments in the Python world. So you just comment out a number of lines and you say, blah goes here, right? You write the first part, you know how to write the first part, you know how to write the last part, and magic is in the middle. So you do comment, 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 magic, and then you go figure out how to make magic work. And that's basically all you're talking about when you're talking about pseudocode. From there, you're going to build a prototype. And basically what a prototype is going to be, it's a vaguely functional version of what you're trying to build, right? So you have the wireframe, and depending on the wireframe software can give more or less functionality. Basically, it's not going to be functional. What the prototype is you're actually going to start being able to click on things. You're actually going to start being able to move through it. You should start being able to add values, get values out, that type of thing. And again, you're able to take that prototype to the users and say, okay, is this working how you expect it to work? Once you get past the prototype, there's something called rapid prototyping, and all rapid prototyping is, basically it's how fast you are, is the whole process of, as you prototype, you get validation from the user, you create a new prototype, get more validation, create a new prototype, more validation, back and forth. Yep.
Is that the same as like CI/CD, or is that a different process?
So that's when you're actually deploying stuff. So when I talked about that whole Agile and where it never ends, continuous integration, continuous deployment, that's that whole Agile process. So basically when they're like, oh, there's a new, hey, there's a new AI LLM we want to connect to, we want it done by today, and then you add that to the system. And then it breaks, and so you go back and fix whatever the hell broke, and you keep going. Yeah, so CI/CD is generally in the actual functional product itself. Yeah, should have put that in here. And then finally, in this whole development process, you get to the minimum viable product. See, the idea with a minimum viable product is a minimum product that is required to actually ship something to the customer. Can you get, or does the customer want to use what the hell you're producing? Again, the whole concept of even if it's free. So that's one thing like a lot of founders don't really want to have to face, they don't want to have to look at, is could you pay somebody to use your product? Like, it's not like, oh, if I give the product away for free. Well, a very painful thing for a lot of founders is if you gave people $1,000, they still want to touch your thing with a 10-foot pole. right? In all seriousness. So the idea with the MVP is actually getting the product into people's hands as quickly as possible to see if they will even use it. Will they use it for free? Because one of the things you'll find out in the real world is many times people just do not care. Again, an interesting thing, like minimum viable product with education. I spun this up in Asheville and failed miserably. They just do not give a crap about this in Asheville. It's like, what? Again, like you are all here, and we've been doing this for like 3 months here. This is going great in Research Triangle. Failed miserably in Asheville, right? And that's one of the things, like with minimum viable product. You just get it out in the world because you may fail for completely bizarre reasons. Again, right? So that's one of the things with the development process. So now we get to AI. So we're going to get to the end of getting close to the end of the class, and we start talking about the artificial intelligence stuff. When you think about artificial intelligence, it's very important to understand that AI does not exist. AI is a marketing term. As I say, it's a marketing term for billionaires trying to become trillionaires. That is all artificial intelligence is. One of the big problems you're going to have with your customers and with your bosses is when you say the words AI, expectations management goes the hell out the window, right? So one of the biggest things as a real technology professional is expectations management. There is nothing like getting done with installing a $20,000 system and having a CEO say, how do you do X, Y, or Z? And looking at them and saying, what do you mean? This system doesn't do X, Y, or Z. And then they look at you and said, the only reason I bought this system was because it could do X, Y, or Z. And then misery ensues. All right, so basically all expectations management is when you talk with a person, right, that's responsible, is that everybody's on the same page. One of the issues that you get to with artificial intelligence, and this is going to be a real problem for everybody here, is as soon as you say AI, people put a massive story on what they think this piece of crap does, right? So one of the first classes we did for Silicon Dojo was, introduction to AI systems with this thing called OLAMA. And which is fascinating with it is I was walking through how to build things. Like, this is how you get personalized information. This is how you build a memory system. This is how you do all this. And what was amazing is how many people said, like, well, it remembers, doesn't it? And I was like, no, we didn't build a memory system yet. Or it knows this, doesn't it? It's like, no, we didn't build that system yet. And that's one of the issues that you're going to run into is as soon as you say artificial intelligence, people are going to assume a massive amount, right? That's one of the big issues. Again, they talk about things like safety. Again, artificial intelligence saying absolutely horrible things. And they say, why is AI racist? Why is AI sexist? Why is AI? All it is doing is pattern matching. Basically, again, it scraped Reddit. What the hell patterns do you think it got out of Reddit, for Christ's sakes, right? And so that's one of the things you're gonna have to think about is like when you're building your systems, how are you going to deal with that? And how are you going to interact, again, with your boss, right? Oh, of course it does X, Y, or Z. It's artificial intelligence. You didn't give me the $10,000 required to do that. You're like, all right, gonna run into a lot of issues there. We're talking about LLMs. I realized I forgot to fill out all of this. Anyways, LLMs and models. When we're talking about these models, these are basically the models that were trained on these things called neural networks. Well, full class on AI later on that. But basically, all of these models do different things to different degrees. Again, one of the things that I like about the Granite models from IBM is that they were literally trained on business communication. So again, if you are going to create a system that is going to be doing business communication, do you want something trained on business communication or do you want something trained on Reddit? Right? Again, one of the big things with Grok, which is really weird, like Elon Musk is really excited about how it's not good, not safe for work or whatever. Again, is that what you want in your healthcare AI system? Probably not, right? Again, that's one of the things you kind of got to think about with the models and things. When you're using the models, the standard unit of resource consumption is something called a token. So when you're talking about tokens, a token is a word, a part of a word, or a symbol. Basically what that means at the end of the day is about 1,000 tokens equals 750 words. So again, if you use OpenAI or any of the APIs, they're going to charge you on a per thousand or per million token basis. So that's basically how you kind of get the idea there. About 750 words equals about 1,000 tokens. They do use tokens for images, and they use tokens for things like voice. So there's a whisper model that you can use that turns a voice into text. With that kind of thing, you're going to have to take a look and see what the tokens actually look like, because that gets a little bit more complicated. When you think about using these models, there's basically different sizes of models. So you hear about 480 billion parameter models. These are frontier models. I guess there's new Chinese models that are like 1 trillion parameters out there. That basically means how much information they know. Basically, how much information were they trained on? The smaller the model, the less information was trained on, but the less resources will be required to run it. So basically, I think the good rule of thumb, they say, is somewhere around like the number of parameters in billions is about how much RAM you need on your system, more or less, ish. I would do it by less. But so if you do a 16 billion parameter LLM, you can probably run that on a system that has about 16 gigs of RAM to whatever adequate performance. But basically the thing to be thinking about is the smaller the model, the less resources it's going to take. The important thing to be thinking about this, again, with these AI services, is what do you actually need, right? If all you're doing is function calling, if you have a list of 50 functions, you don't need this damn thing to understand what Shakespeare is, right? I just need it to understand which function I'm looking for, and that's something to consider. That's with sizes. You're going to hear about quantization. So what quantization is basically the compression of these models. So this gets into very sophisticated math that's well above my head. But apparently an unquantized model is 32-bit floating point. And then they compress it to 16-bit and 8-bit and 4-bit and 2-bit and 1-bit. The idea is that the amount of data the thing was trained on is the same, but that the precision goes down. So the idea is, okay, this is trained on absolutely everything, but how precise it's going to be basically gets worse with how much you compress it, which again depends on how much you care. Again, something to think about, just as I think about with the model sizes, for anybody here that's international, deals with other countries. Korea, South Korea apparently actually just came out with a really good small model that works really well in South Korea because all it knows is Korean. Again, which is one of those interesting things, like with all these, like the OpenAI model, like you can talk to it in any language around the world because it's been trained in all these different languages. Again, when you do that, you get these hallucinations. Again, hallucinations aren't hallucinations. Hallucinations are just errors. Again, it's statistically trying to put things in order, and it just simply puts incorrect data in order. That's all you get with a hallucination. So the more data you train model on, especially the worse the data is, the more hallucinations you're going to get. So it was interesting, again, with South Korea, they just trained a model just on Korean, and apparently they're very happy with it. They're like, ooh, it's a Korean model. Anyways, things to think about. When you get actually into using these AI systems, there's going to be something called prompt engineering, and prompt engineering is fun, I suppose you could say. It's interesting, right? So most of the stuff that you do in the programming technology world, it's very simple, right? It is this key equals this value, and you write that in some fashion. You may click off on a checkbox or radio box. You may go in with Nano and edit some code or whatever else, but normally that's what it is. What's interesting when you get into prompt engineering is, again, these LLMs, based off of their training, will essentially, it turns your query, your prompt, into these things called tokens, figures out the statistical relationship of all these tokens, and then from that, automagically comes up with a response, right? And it's basically putting tokens. That's the important thing to understand. It's not putting words in order. It doesn't understand. It's putting tokens into order and then kind of flipping over what those tokens mean to give you words. So one of the interesting things you get to with prompt engineering is literally based off of how you write the prompt, it will give you different responses. Again, the specific words that are used and that type of thing, must have, you'll see this, a lot of people now say, tell the prompt must or never. And that's one of the things to consider when you're doing the prompt engineering. And the other big thing to be thinking about with prompt engineering is, again, we talk about service-oriented architecture, the idea of being able to swap services. Remember, so normally, like if you're dealing with Twilio and sending out an SMS message, so let's say I want to get rid of Twilio and I want to use another SMS provider, right? Again, all I have to do is figure out the configurations for the new SMS provider. I have to figure out what the error codes that are going to come back are. I'm just going to have to rewrite my code. It's very tedious and annoying, but you know how to do it. One of the curious things, when you swap out the code for an AI service, your prompts might not work right anymore. So you swap out the API key, and you swap out the connection, you swap out all that stuff. That's fine, whatever. Again, tedious, horrible, it's nasty, but that's what we do. The problem you might run into is literally your whole list of prompts may not give you the responses you're expecting. And then you get into that disaster. So something to think about with prompt engineering there. Again, one of the weird things that's come up too is thinking about how data comes back. So we talk about parsing. And so what parsing is when your program actually reads and does something with the text coming back in. I've been talking to a lot of people dealing with these AI systems. And it's curious. Again, remember, these LLMs are trained, especially a lot of stuff that's on the web. So one of the data types that's on the web a lot is XML, right? Almost every website has what's called an RSS feed that has everything formatted in XML. So what's curious is talking with a lot of the developers, what they found is that a lot of these LLMs understand XML exponentially better than it understands JSON. So again, that's one of those weird things too. Like what you might need, like if you're getting bad JSON responses back, what you might have to do is ask for an XML response so it gives you a better XML response, and then you write your own Python code to turn that XML into JSON. And that's kind of weird crap you have to deal with these prompts. You then get into what's called context engineering. So the prompt engineering is basically the query itself. The context is everything that is going to get shipped off to that LLM in order to answer the question, right? So basically, this may be things like prompt injections. So whenever you do the Silicon Dojo class, one of the things we always do is we do an injection of answer in 20 words or less. And so we just add that to that context window. Because again, if you use LLMs, they are very verbose. They will, hello, and they will just give you a book on hello back, right? Anyways, so you say answer in 20 words or less. So that's a very simple thing like a prompt injection. When you get beyond that, you get to something like retrieval augmented generation, something called RAG. And that's where you have a database system. So when somebody asks a question of your AI system, basically what happens with RAG is you have all of your documentation for your company or your organization. All those documents are turned into chunks. So I think it says like 300 to 500 token size chunks. So somewhere about 300 words. So each document is turned into chunks. Basically what happens then is it goes through an embedding algorithm. And so that embedding algorithm is basically used to create this thing called an embedding that goes into a vector database. Again, very complicated math. When you actually do it, it's just a couple of extensions that you add. And basically what happens is when you write a question, when you write your query will get turned into an embedding too. And using very sophisticated math, it will what's called a vector database will try to figure out the distance between your query and all of these different embeddings within the database. And essentially it finds the embeddings that are closest to what you're asking. So the idea here, the unsophisticated idea here, is to find any chunks that might have an answer to the question that you're asking. And so what happens then is the embeddings get matched, and then the text from those embeddings all get added to the context window. And so your injection, your query, and all the RAG comes back, and all that gets shipped off to the LLM to try to give you the answer back. And again, and that's the other thing to be thinking about when you're building these AI systems is I did an interview with somebody that's actually creating a big old RAG infrastructure. And one of his arguments for like with fine tuning or the LLMs versus RAG is that RAG should give your AI the knowledge. The LLM kind of gives like the flavor and how it talks. So kind of like the verboseness. So the idea is you don't train the LLM or you don't fine tune the LLM on all of your documentation. You put all of your documentation into the RAG system, and then you have the LLM be able to query the RAG system to be able to give you the response. And again, and this is where these will be many classes. Again, as I tell everybody, if you're new to this, try to walk away understanding two things. If you learn two things in these classes and you come back 3 times every month, it's amazing what you'll learn in a year. The important thing to understand with this, even if you don't understand RAG and context windows and prompts, this doesn't fit in. What I want you to understand here is think about all the systems we're talking about. Again, we talk about artificial intelligence, like there's this magical idea of what AI is. And they start talking about prompts and languages and models and context windows and RAGs and API calls. And this is what I really want you to understand, is all AI is just another stack, right? again, does amazing things. But anyways, that's what we're talking about with vector databases and stuff. Again, we'll have a whole class on that. A lot of this too, it's important to understand. It's very interesting seeing artificial intelligence kind of here now. It reminds me a lot of when I got my MCSE. So when I got my MCSE 20 years ago, oh my golly, right? Oh, I had to spend so much time learning so much about encryption. Like, there's all this stuff that you had to learn, Cerebros, whatever it was. Anyways, the funny part was, they made you learn all of this. There was just a book you had to learn about things like security and encryption. And then when you actually went to the server, there was a checkbox. Basically, you learn all of this stuff, and then you go to the server, and it's like, should I use this encryption? Yes. Done, right? So one of the things I do want you to be thinking about, again, if you're going to be implementing this, is when you start when you start reading about the things like the neural networks are amazing, but Jesus, they're going to make your brain melt. Like, there is so much math involved. And again, computer science, that is the science component. And one of the things with a lot of this is one of the reasons this is going to be difficult to get your head around is because there's the science component, right? The very sophisticated way how all this works. And then there's the product where it's 5 lines of code, right? And one of the things you're going to have to figure out is what's the difference between this very sophisticated stuff that doesn't really matter and how you get to that 5 lines of code. And again, like with RAG and that kind of stuff, that's going to come up. Let's see here. Local versus API for things like API services. When you're thinking about building these AI systems, again, are you going to have a local AI system, a local LLM system, or are you going to use OpenAI? Again, with some of these API calls, and this is where you have to understand, you have to think about architecture. Again, when I was talking before about videos, right? If you are distributing 2-hour 4K videos, you really have to think about whether you want this as cloud architecture or local architecture, because again, you're going to get charged 9 cents per gig that goes out, can get very expensive. One of the things to realize is OpenAI right now really likes to burn money. They just love to light money on fire, right? They have literally committed to 1.3 trillion, they've committed at this point to $1.3 trillion of contracts. And the amazing thing is, you can get access to all of their infrastructure for $1.50 per million tokens. So one of the things you really do have to ask yourself is, like, I see this a lot, like, again, being in the YouTube world, one of the things that's getting pushed right now is this whole idea of clustering these really powerful Mac Studios. So there's these Mac Studios. You can get them with 512 gigs of RAM. You put them into a cluster. There's this whole, it's from a technical standpoint, it's amazing. They can actually share their own memory. So everything kind of is like working almost like on one system. But like, that costs 50 grand. That's $50,000. Again, technically amazing, but it's 50 grand. Again, $1.50 per million tokens. Like, how long will it take you to get to $50,000, right, at $1.50 per million tokens? Something to really, really consider with this kind of thing. The other thing to be thinking about is required response time. So this is a big thing with a lot of this AI hardware. Again, whether you're talking about these, $50,000 Mac Studios or these $40,000 NVIDIA GPUs, is what response time do you need, right? So we did a class a couple weeks ago on pushing AI to the edge using Raspberry Pis. And so on a Raspberry Pi 5, you can run a vision model called Lava, which is a very powerful vision model. Here's the thing. It takes 5 minutes per response on a Raspberry Pi 5. Right? If you run it on this thing, it'll take like 30 seconds. If you run it on a $40,000 NVIDIA GPU, it'll take like 5 seconds. But on a Pi, it takes 5 minutes. And so a lot of people would look at that and say, that is too long. That is ridiculous. That will never work. Well, something to think about. Like, if you have a marketing department, and let's say you have this marketing department has a few thousand pictures that have been taken over the past 10 years. Let's say they add a couple of hundred pictures per day into that database or into their system. And let's say they just need a taxonomy, right? They have all of these images. They have no idea what's in the images. There's no way to tag them. There's no way to search because they're just images. So basically, if you have a Raspberry Pi at 5 minutes per response time, that comes out to 12 images per hour, that comes out to 280 images per day, that comes out to, 14, I don't know, bad with math, let's say 18,000 images per week. right? So imagine you turn this thing on 24/7. Let's say you have 10,000 images. Let's say it takes a month to process the first 10,000 images. And then after that, again, there's only a few dozen images per week that go in. You might actually find that a Raspberry Pi 5, right, a $150 computer, actually is able to process those images completely fine for whatever your particular task is. So again, that's one of the things you have to be thinking about when you start designing these systems is really like, what do you actually need your response time to be? Again, like with Silicon Dojo, when we do the in-person classes, our lab computers are 2012 MacBook Pros. So these are 14-year-old computers with 4 gigs of RAM. And again, they can run Granite 4 350 million parameter model on one of those things. So again, do you need a $40,000 system? And that's one thing to think about when you're dealing with the executives. Something that gets missed is they only have so much money. Like there's this weird idea that they have all the money in the world, but they're just not going to give it to you. They don't like your face. They're like, oh, guys, look, they have to pay for servers. They have to pay for you. They also have to pay for toilet paper. They also have to pay for coffee, right? Again, if you really want to know your job is about to get bad, when your company goes from the premium coffee to, at least back in the, I don't know what the current crap coffee is, but back in the day, it used to be a Lion coffee. Like you go into office and you have like a year, you've had Starbucks coffee, and you're like, yeah, we get Starbucks. Again, this is 15 years ago. Wait, like, we got Starbucks coffee. And then one day you walk in the office and it's Gold Lion coffee. You're like, oh, crap, everything's about to go to hell, right? Because that's the thing, right? There's only one pot of money. And so that's something to think about, like when you go to the executives, is if you are actually focused on money, if you're actually trying to save the money and explaining, look, this product will actually give us the performance we need at this price point. Again, if they can save $40,000, that might be what actually keeps you in your job, that type of deal. Things to be thinking about. Let's see here. Speed of change. This is going to be a big one for a lot of folks in here if you start deploying AI systems. So I've been doing these AI classes now for a couple of years, about 3 years. One of the things I found that's very weird, right? So the entire point of doing these classes is doing the class itself. This is pretty easy, right? It actually takes me about a week and a half to actually create the class itself normally. This is an easier class. But it takes me anywhere between days to 2 weeks in order to create a class. So the idea is I create the class, I do all this effort, and then I put it on the shelf, and then I just rinse and repeat, right? Every quarter I rinse and repeat, right? Python, fine. Linux, fine. SQLite, fine. AI crap, every quarter, this stuff changes. It is amazing how many times I've created an entire class, I've taught an entire class, everything's gone great, I put it on the shelf, I pull it down 4 months later, I simply go to run the code just to verify it works, because I'm paranoid that way, and it's good, because nothing works anymore, because they changed something in their system over the past 4 months. The reason this will become an issue, especially if you start deploying things, is most of the time, if you deploy systems properly, they don't need a lot of preventive maintenance, realistically, right? Systems need to be updated a little bit, but they should just do what the hell they need to do until there's an upgrade. One of the issues you might run into, this is a very concerning thing, is if you have all of this code written, everything's working perfectly, it's a year from now, you decide to update the modules, you decide to start updating things, and all of your sudden, all of your code starts breaking, because the latest module doesn't work with the code that you wrote before. So that's with, like with OpenAI, I dealt with this about a year and a half ago. So OpenAI used to send back collections in Python. So you use Python, and basically it's like you use square brackets. So it'd be like response, square bracket, content, square bracket, message. Anyways, that's what the response was. About a year and a half ago, they decided to change all that. They decided to send back classes instead of collections. And so after that, you had to do response.message.content. So it was still the same key path, but it literally had to be formatted differently. And again, that was one of the weird things that I was just about lost my mind that day. So something to think about there. The other thing to be thinking about, again, in the artificial intelligence world is, would an if-else statement work better? I think about this a lot with things like keywords, especially if you're talking to a system, and this is the whole thing, like, is educating your employees easier than building a system? So again, with some of the projects that we've done, again, with things like function calling, if you say, what time is it? Like, you can literally just do a Python where it says, if what time is it in string, fire the time function off. And so again, that's one of the things you need to be thinking about is, do you really need a lot of AI functionality, or do you just need if-else statements and to train your users on how to use specific keywords? Might make your life a lot easier. Finally, getting to the end of this, a big question is SQL and AI. Again, this is an interesting thing that's coming up. If you follow my LinkedIn, I just shared a post from a big company that's dealing with this. So right now, a lot of how they're trying to use AI systems is they want the AI system itself, the LLM itself, to parse data, right? So you send a spreadsheet to the LLM, and you say, give me interesting data out of the spreadsheet, right? The thing to understand, these LLMs require a lot of resources. Compared to almost anything else we do in the computer world, they just burn half a forest in order to get you that answer. The interesting thing is we have other technologies. So SQL, again, structured query language, when we talk about these things called relational databases, one of the things to consider is, do you really need to send all the data to the LLM for the LLM to process the data? Or do you need to ask the LLM the appropriate SQL statement to pull out the information that you're looking for, and then simply run that SQL statement? And then beyond that, cache that request response, so in the future, when somebody asks the exact same thing, they get that cache SQL statement instead of even having to ask the LLM itself. And so again, that's one of the things we think about this whole architecture thing, is really, where do we want this intelligence, where do we want this stuff to actually be working at? Do we want it working at the LLM? Do we want it to work at SQL? That type of thing. MCPs and alternatives. So we'll probably have a class on MCPs in the next couple of months, if MCPs are still around. When we talk about MCPs, this is called Model Context Protocol. So we talk about REST APIs. So we've done classes on REST APIs and APIs. This is simply how you communicate with a vendor systems. The idea with MCPs is MCPs are basically, they're a protocol for artificial intelligence systems to talk with other artificial intelligence systems. So this whole thing, and it's a mess, and I have to draw it out in order to teach you guys a class on it, but there's this whole thing where there's like a tools manifest, and so it's a client server architecture. The server has a whole bunch of tools. So when the client basically asks the server, what tools do you have and how do you format a request? Those tools, that tool information is then sent to the client computer. It gets that information. It figures out how to format a request. Then it sends it back to the server, and the server gives a whole bunch of information. That's basically what we're talking about when you're talking about with MCPs. The important thing to understand, though, when you're talking about the MCPs is, again, 6 months ago, everybody was all over MCPs. MCPs are the future. I've been talking to more and more people that do AI, and they're like, MCPs was 6 months ago. So just something to keep in mind, like when you're talking about MCPs, the idea with an MCP is that one AI system can communicate with another AI system in order to accomplish some task. Whether or not people are still using MCPs in a couple of months, who the hell knows? It is just one protocol. Again, we talk about protocols. All this is basically how systems are supposed to communicate with each other. And then finally, I guess we're finally to the end of the class. 2.5 hours. We're talking about AI agents. And so this is going to be an important one that's coming up. And so this is supposed to be the future. And again, I have a real question with that, because are they really that complicated? All an AI agent does when we talk about AI agents is they're an AI system that is able to basically do something on your behalf, right? So basically it is able to schedule a hair appointment for you. It is able to, again, schedule lawn mowing. It's able to do that type of thing. The curious thing is when you start looking at these AI agents, they start really looking like a lot of API calls. Like basically, if you look at the AI agent, what you can do is you can say, hey, AI system, I need a haircut, right? And so it already knows where you want to have a haircut at, who your barber is. Maybe it knows a couple of other preferences. So it can query the barber system, what are your open calendar dates? It knows that you want something in the afternoon, so it finds something in the afternoon, and then it basically just sends off some kind of REST API or some kind of API call in order to claim that afternoon spot. That's basically all we're talking about. We're talking about agents. And again, if you start looking at these things, it looks like 10 or 15 lines of pretty normal Python code, really, at the end of the day. So that's what we're talking about with that. And that's where we do agents and actions. And I don't know, hope that class made half an ounce of sense. That is the kind of an introduction to programming in the whole world of AI. And yeah, any questions? No question. Yep, question.
We'll go back to the quantization.
Yeah.
So the gain of that is that, so we're shrinking down the amount of the data it's storing. Is that sort of supposed to give us a quicker response when we're actually prompting the AI, or is it shrinking the actual file size?
So yeah, so
Or I guess what's the upside of it, I guess? Because I know you lose accuracy.
yeah, so you lose accuracy. So the idea is that you shrink it so you can use it on less resources of a system. So the idea is you could use a 480 billion parameter model on a system that wouldn't normally be able to run 480 billion parameters. And so again, so it has all that. It has all of Reddit. It has all of Twitter. So like that's the interesting thing. Like if you use a smaller model, like the 350 million parameter model, it has like almost no information on anything political. Like if you ask like who was the Tsar of Russia in 1900, it's like, oh, that's politics. I don't want to get into that, right? And really what that is, they didn't train it on it. So the idea is it still has all that information, but they shrink it down. Again, very complicated math processes, so it'll run on smaller systems. Yeah. Yeah.
Yeah, speaking of training data, are AI companies or like language model companies usually like open about like their training data? Like I assume like they aren't like showing us like, oh, this is our full training data set or anything, but like do they show us like I don't know, like, oh, we for GPT 5.2 we started training on this data set or something like that?
Normally, they might tell you some of the data sets. That's one of the reasons, again, I like IBM, is they actually tell you the data sets they trained on. The problem with OpenAI, again, probably, most likely, is that it was illegally trained. Because that's one of the big things. Like when they're going to court with the New York Times and all that, like it's really fucked up. The New York Times has to prove that their system was trained on the New York Times. But again, it's not a normal database system. Like a normal database system, I would scrape the New York Times, you send the FBI in, the FBI raids my data center, you grab the database, and you can see all the scraped files, right? The issue with this training is, again, it turns it into these models. Like when you look at these models, it's not text like you know it. So that's where it's like they've trained it on all of this, again, stuff that they weren't supposed to. And so, yeah, they won't tell you. Yeah. Yeah. Yep.
It was interesting to hear, like, take AI as a concept of just a stack.
Yeah.
Just visualize it that. So can you give an example of, like, what a typical stack would comprise? Like, for example, you talked about LAMP or more, but, like, and they had, what is in the stack in a way, but I was wondering,
Yeah.
can you give an example of, like, what a typical...
Well, I don't know, like a typical stack. Let me see if my little eraser works here. But like, so like, hopefully with the Twilio thing, again, I've got to still make sure the Twilio thing actually works how I think it will. Where is my eraser? Uh-oh. Oh, there it is. Oh, crappy eraser. So, all right. So like if you think about like a stack, right? So let's say you have your person and they're making a call to, I don't know, a plumber, right? And so we're going to do this whole voice Twilio thing. So basically, when you start looking at the stack, when they do the communication, that communication is going to use Twilio's voice services, right? So there's a whole voice over IP thing. So they call. So you can actually buy a telephone number from Twilio. And so people can call into that telephone number, and then Twilio's voice infrastructure will take over from that, right? Once that comes in, right, it's going to be voice. So somebody is going to be talking. So that's where, like OpenAI has something called Whisper. And so what Whisper is it's a voice model. So it will take what you're saying and will actually turn that just simply into text, right? So then once you have that text, that will then go into your Python code. And that's where we go into the whole context window thing. So you're like, hey, I'd like, and you say, let's say you say, hey, I'd like to know, do you install certain water heaters, right? So basically what's going to happen there is that query is going to come in, and then that will go to the RAG system, right? That database, that vector database thing. And basically anywhere where they're talking about water heaters, those chunks are going to come out. And so what's going to happen is your query plus this information that's coming from the RAG that will go to the LLM, right? So that might be OpenAI or Granite or whatever else. And so basically what the LLM is going to do is going to say, okay, this is the question. This is the information I should use in order to answer the question. And then that question is going to come out. Well, that question is going to come out, and that question is going to come out as text, right? But this is a voice call. So that's where that text is then going to go through 11 labs. And 11 labs, what that does is that turns text into voice. So now it'll be a voice response of the secretary. And then basically that will then get shipped back up through the Twilio API, then go back out to the user. So that's kind of like what you'd be looking at, like when we start talking about the stack. And again, that's why I say, especially with AI, the stack, like we're not talking about LAMP stacks. I miss the days of LAMP stack because it's just like blah. But this is where we start talking about like, yeah, what the technology stack would look like. Yeah. Any other questions? Yep.
Yeah, sorry, I'm really fun.
Yeah.
So for distributing, like, back to interpreted languages, so,
Yep.
like, say if I'm, like, for an example, I'm going to be working on this later, but,
Yep.
If I'm, like, prototyping something on my desktop and I want to, like, deploy it to, like, a VPS or something later, and, like, you know, I'm using Python, of course, like, I know I could just, like, install Python on the server as well, but, like, is there a better way to, like, distribute, scripts or like any kind of like app or service that's like made with an interpreted language? Like, do you package it with like the interpreter, or what's the best way to do that?
Again, with me, especially doing education stuff, I just put it up with secure shell, SSH it up. Depending on how you're trying to deploy it, like a lot of people nowadays package with Docker.
Okay.
Again, I've learned a lot of technology, so I gotta learn more. So Docker was one of the new ways everybody packages everything. So a lot of people just package your thing in Docker. So it's like, if you package it within the Docker container, then you can just simply upload the Docker container, basically set it to run, and then that's all you have to do. So that's how a lot of folks are deploying stuff nowadays. But yeah. Yeah, okay, yeah. Yeah, again, it also depends on like how complicated you want it to be. Like, is it a very sophisticated platform where there's a lot of things working together? So you really want to keep that as one whole, or is again a couple of scripts that you just want to put up there? Yeah. Any more questions? Yep. What's that?
When are you planning to have your next class?
So the next class will be the 11th. So again, it'll be February 11th, and then 2 more. So we'll have 1 Saturday class. So we'll have 2 Wednesday classes in February and 1 Saturday class. It'll be the 11th, and then whatever is 2 weeks after the 11th, and then some Saturday in the middle there. Yep. Again, I'll be posting that hopefully in the next couple of days. Yep. Questions? Any more questions? Well. Cool. Well, as a class, you guys can chat and hang out, whatever. We got the place for a while. Again, take the paper, not the book. Take the paper, not the book. If you want the paper. You don't have to take the paper.
Thanks for the class. This is
Yeah.
really interesting.
It was good. Yeah.
Also,